Hello, jury members, students, teams, and faculty advisors. A very good morning to you and welcome to SDI Finals. This is the on-site construction worker housing division, and the on-site construction worker housing division is a path-breaking division in SDI. So it addresses the real problems that are faced by millions of Indian workers. We know that construction workers already live in abysmal conditions in terms of safety, hygiene, and comfort. And often these conditions affect women workers the most. So the teams in this division have developed a very good understanding about the problem and attempted to provide a good quality housing for the workers. And I'm excited to welcome you all to the presentations on the on-site construction worker division and to find out how these students plan to transform the lives of construction workers in India. My name is Amritraj, and I'm going to be your jury coordinator today. And it's my job to keep us on time. And I'll be taking this part extremely seriously, okay? So our finalists have put in a lot of work, okay? And they've submitted the projects about a month ago. And today, these teams will be here presenting their work to our jury. So the on-site construction worker division has 3 jury members and with expertise in net zero and resilient buildings. So we have Alok Deshmukh from Delhi, who's the co-founder and managing director at Superhuman Race Private Limited, providing CSR, ESG, and sustainability solutions. Hello, Alok, and welcome to SDI Finals. Next, we have Manjunath BL from Bangalore, and he's an independent structural consultant. Manjunath, welcome to SDI Finals. And a third jury member is Surya Kakani from Ahmedabad, and is the founder and principal at Kakani Associates, an architecture and design company. Hello, Surya. Welcome to the SDI Finals. So these jury members have had about 3 weeks, to review and review the reports that the teams have already submitted. So they have looked at your work in detail. They have already assessed your entries for the 10 contests of the Decathlon, okay? So teams, your presentations will help them to hear your narrative. And they will assess your presentation and your mastery over the solutions through a Q&A session. And they may even revise their scores based on what they hear from you today. And I'm excited to have you meet the teams today, our jury members. And specifically, I will need to interrupt you people, including the teams as well as jury members, from time to time to help us keep on track, okay? So please don't mind, okay? I'm looking for your support in this one, okay? So please keep your comments and your questions short and to the point, okay? Are we ready to begin? Okay, all right. So we're going to start with the presentations now. Our first presentation is from Team Echo. So they have worked on a construction worker housing project for a bedded multi-speciality hospital in Haldwani, Uttarakhand, correct? That's right, yeah. So, and the project partner is Uttarakhand Payal Nigam. Okay, okay. So could you please come up on stage, the presenters? Yeah. So I'll be providing some instructions to the team now, and I'll be providing these same instructions to every team before their competition and before their presentation. So every team will get these instructions. So Team Echo, you will have 20 minutes to present your work to the jury, okay? At 15 minutes, I'll give you a visual signal. I'll raise my hand right here, okay? Sorry. So I'll raise my hand and let you know that your 15 minutes are up and you have 5 minutes remaining. So you will not get a 21st minute. At 20th minute, I'll physically stop you if you have not completed your presentation by then. So after your presentation, we will have a 10-minute Q&A session with the jury. Please keep your answers direct and to the point, okay? So the stage is yours. I'll let you know when to start, all right?
Good morning, one and all present in the room, respected jury members, visitors, our fellow competitors, and people watching us on YouTube. We are Team Echo from DIT University, and we are here to present our work and project on on-site construction worker housing under the Solar Decathlon India competition.
A team of budding architects, UX designers, and civil engineers have come together to participate in this competition. The term echo is often used to describe repetitive or reflective sounds. Similarly, our team aims to provide solutions which have a resonating impact on the future generations.
Construction workers are unsung heroes who put tireless efforts day in and day out for the upliftment of lifestyle of the stakeholders. And they themselves live in poor living conditions and challenging living conditions on site for a duration of about 12 to 24 months, depending on the magnitude of the project. They create temporary homes compromising on the aspects of safety, health, comfort, and convenience. There is a lack of community spaces. There is a lack of optimization of materials, land, and efforts. Our proposed site is located in Haldwani, Uttarakhand, which is a 200-bedded hospital, multi-speciality, and an area of 2,100 meters square is allocated for construction worker housing. Our project partner, Uttarakhand Pejal Nigam, is a government organization which is responsible for design, execution, survey, and design of the water supply and sewage of the state of Uttarakhand. Their brief was very simple to us. Their requirement was a construction worker housing for 75 people and with a duration of 18 months. They had 3 more requirements. One, that the module should be easily fabricated, assembled, and dismantled on site. Number 2 was that it should just take 15 minutes for them to assemble the module on site. Number 3 was that minimum residue should be left on site after the completion of the project.
The 3 major issues on project site that we observed were the Uttarakhand lies in seismic zone 4 and is prone to frequent earthquakes. Being near to the forest area, there is a constant threat of wild animals getting into the premises. Uttarakhand lies in a composite climate zone and hence Haldwani experiences extreme weather conditions during monsoon season. Some of the potential solutions we provided inferring to the site problems and according to the requirement of our project partner, we provided a strong dwelling unit which can withstand extreme weather condition and provide safety from wild animals. For doing so, we also considered proper ventilation, daylight, drainage, sanitation, and provision of open spaces. Architectural design of construction worker housing unit for composite climate of India. The design has been carried out by considering various aspects like safety, comfort, convenience, daylight, ventilation, and commercial viability. The plan has been segregated into 2 parts, Alinda and Shala. Alinda or veranda, meaning measuring 1.8 meters into 2.7 meters, is an ideal place for performing daily household activities in all season, as this is the space which receives natural daylight and breeze throughout the day. Shala or room is a private living zone for which adequate provision of daylight and thermal comfort are considered. A standard module size of 4 meter into 2.7 meters has developed considering a bed size of 1.8 by 1.8 meters with adequate circulation space which is 0.9 meters on all 3 sides of the bed. Orientation of dwelling unit is considered with due respect of the cardinal direction so that the head of the occupant is always on the south direction while sleeping. By doing sun path analysis using design builder, we get an idea for placing the perfect place for windows, doors, and position of bed, skylight, and solar panels to harness energy.
Customization of module can be done as per the requirements on site. The living space of the module can be converted into an infirmary or a crèche. The veranda that is used for the daily activities can house a small convenience shop to cater the needs of the workers. Solar panels are to be mounted on each module with an inclination of 30 degrees, that is the latitude of the location. Openings are provided for optimum daylight and thermal comfort. 4 windows measuring 0.8 by 0.0 meters are provided, 2 on the north wall and 2 on the south wall. North light is provided for getting diffuse light inside the dwelling unit throughout the day. The truss can also be used to hang clothes at the night time, and enough storage space is provided for a family. Customized wall sections, roof, and floor are worked out after carrying out exercises and analyzing the thermal performance of various concepts, which is cost effective, visually appealing, easy to fabricate, transport, install, and dismantle after the completion of the project. These materials are adaptable to be reused. A composite section, 63 mm thick, comprising of laminated shuttering plywood on inner and outer face, sandwiching the layer of insulating material, is considered for walling. Roof panels of PU foam sandwiched with GI sheet have been used for roof assembly. PUF panels are good heat insulators, and they protect the inner environment from adverse weather conditions, which make them easy to adapt in all geographic locations. Sections can be customized by changing external material from shuttering plywood to 8 mm thick rice husk board for hot and dry climate.
Shadow patterns are studied for various seasons or throughout the year, which confirms that the wall and the window of the dwelling unit will receive maximum solar radiation during winters, which is desired, and will be shaded during summer, which is to be curtailed. Feasibility of harnessing solar energy was explored and confirmed by studying yearly sunshine hours and radiation for our site. Module and construction details are considered, which are simple to fabricate and easy in assembly and dismantling of the unit in 9 major steps. Leveling of the ground, fixing the base plate with the cement mortar to ensure leveling, fixing MS column over the base plate, assembling the network of flooring level joists, laying the flooring panels at plinth, and assembling the wall panel with the columns, assembling the network of lintel level joists with the column, fixing the trusses over the lintel level, assembling the roofing panels, installation of rooftop solar panel and internal electrical fittings and fixtures. Total 34 dwelling units are placed on the allocated site to ensure an ambience within the residential zone which is welcoming and convey the feeling of safety for all construction workers on the site, as well as which help in enhancing their productivity during the working hours. Common amenities like crèche, infirmary, separate toilets for men and women, common kitchen, daily need shop, supervisor's office, and community open spaces are provided on site. Solar cookers are proposed for kitchen having a capacity of 20 liters per cooker. 3 such cookers are installed in a separate open kitchen to ensure maximum uses of renewable energy on site. Provision of solar water heater, bio-toilets, rainwater harvesting tanks, and water recharging pits are given on site. About 40% of site area is reserved for green, and paved areas are provided for all amenities.
Architectural details have been kept simple for the ease of fabrication, assembly, and dismantling. The details P and Q here explain the mounting of solar panels and the joinery of trusses with the sections, and the sections have been chosen judiciously considering the IS codes. The detail R over here shows the foundation and how the floor is connected to the beams and the angle sections. The detail T shows the ridge section. The detail S shows how the roofing sheet is connected to the trusses. Detail U is the section of how the wall is connected to the window sections.
The module consists of 4 main dismantleable components, that is foundation, wall assembly, floor assembly, and roof assembly. The foundation consists of base plate measuring 300 mm by 300 mm, which is 6 mm thick. Floor joists rest on the angle sections welded to vertical box sections. Floor assembly consists of inverted C-beams and T-sections on which the floor panel is placed. The wall panel assembly comprises of shuttering ply sandwich panel with GI edging. They rest over the floor joists and are held in place by primary as secondary columns. Primary columns are C-sections welded back to back, and secondary columns are rectangular hollow sections of section size 60 mm by 40 mm. These columns are tied at the top using inverted C-section beams with the help of flat plates, nuts, and bolts. Roof assembly consists of 4 trusses over which the purlins rest that hold down the roofing sheets. The solar panel assembly is also mounted on the trusses to bear its load. So coming on to energy performance, TPS 300 panels have been used for load calculations. By using efficient lighting fixtures and energy-saving electrical fittings, the EPI has been reduced to 23.98 kilowatt-hour per square meter per year from 34.48 kilowatt-hour, which comes under 5-star rating of BEE. Site has the potential to generate energy through renewable sources, which is 1.5 times more than the annual energy consumption. Detailed table has been included in D4 document, which explains the usage of electricity throughout the year. This slide shows the electrical layout plan for our site. Street lights and CCTV cameras have been placed judiciously on site to ensure safety of the residents. All electrical services are managed from the electricals and battery room provided at the entrance of site. In a single module, electricity has been provided for a wall-mount fan, a tube light, and a 6 ampere socket for mobile charging. Flow of electricity is regulated by the on-grid solar power inverter located in the battery room. The energy generated from rooftop solar PV panels goes to the inverter. The inverter powers the modules and charges the battery throughout the day. If excess energy is generated through the PVs, it may be sent to the grid, which is metered by the bidirectional meter. In night time, 150 Ah cross 20 batteries power the modules, which is enough for 2 days of power supply if there is no supply from the solar PVs.
Maximum solar radiation is received on the south face, which suits the installation of rooftop solar panels at an angle of 30 degrees, which suits to harness the solar energy. Solar PV panels also provide shade to the roofing system, which control the rise of indoor temperature. During winter season, solar radiation is received on south wall, which helps in warming the indoor air. Simulation results indicate that a total lux level of 50 to 100 lux level is achieved on floor level during daytime under the clear sky condition. Diffuse daylight inside the module throughout the day from north light and the windows.
Generally, an individual uses 135 liters of water per day. By using efficient fixtures, we aim to reduce the consumption by 30%, that is 96 liters per capita per day, which is the typical water use in our site and is estimated as follows. Starting from the source, 72 occupants will require approximately 2,847 kiloliter water per year, which is being sourced from the municipality water line. Total water quantity is stored in 2 overhead tanks of 2,000 liters and 4 overhead tanks of 1,000 liters each. Out of this, 146 water is being consumed for drinking and cooking respectively. At macro level, sanitation is looked into detail on site in order to cater all aspects of water and drainage. Open stormwater drains run across site carrying water to the sedimentation tank below the ground level. Grey water from kitchens, bathrooms, and wash basins is carried to the ETP on site, which is of 5 KLD through closed drains. Also, underground channels take black water from WCs to on-site STP of capacity 2.5 kiloliters. Water from drains is collected in the chambers and used for rainwater harvesting, which is through the 2-inch pipe of perforation into the soil. Separate toilets are provided for men and women on site. Each toilet block is fitted with 2 water tanks and 1 solar water heaters of 500-liter capacity.
Proper wall-window ratio for thermal comfort and natural daylight. Ample daylight in veranda to carry out day-to-day activities. Materials and finishes are considered which do not impose health hazard on occupants. Adequate toilet facilities for male and female. Storms occur occasionally on site. Hence, there are no trees placed on the east side of the facade. Pathways for convenient pedestrian are provided. Dharna is a business model for construction worker housing wherein the promoter or the investor has to invest in the fabrication and procurement of materials. These portable shelters can be leased out. The specific regions that they can be leased out can be from a range of 150 kilometers to 300 kilometers from the radius of the warehouses. These modules are specifically for the composite climate of India.
With the specifications of our project and taking references from the Delhi Schedule of Rates 2021 and commercially available materials, the cost estimate we prepared concludes that the hard cost of the CWH module, that is capex, is rupees 7859 rupees per square meter. Moving on to the economic feasibility, we have considered a case where a worker would spend 10% of his daily wages to accommodation, which is a standard by house rent allowance by Government of India. We are providing them the CWH facility for about 60 rupees per day. Daily income of construction worker varies from 600 rupees to 1000 rupees as per our case. CWH facility for 75 workers shall cost rupees 24,60,000 to the project partner, which comes out to be around rupees 60 for per construction worker per day. Commercial viability is verified through this table, which explains about the cost of CWH facility for 18 months to project partner. A scrap value of about 12 lakh rupees will be regained by project partner after 6 cycles.
Following provisions are considered in architectural scheme for the purpose of resilience. Single-story dwelling units to ensure zero damage during earthquake. Raised plinth level ensures zero water entering the modules during the flood. Lightning arresters to prevent any lightning strikes. Sturdy fencing provides safety of workers from wild animals.
So a model of CWH has been proposed to create and ensure an ambience which is welcoming and conveys the feeling of safety, comfort, convenience, and belongingness to all construction workers. We will continue our efforts to fine-tune the details while using new and innovative materials for better usability, comfort, and better environment. We have also prepared an installation and storage manual for easy operations that we have given to the jury members. Thank you so much.
Okay. Job well done, Nico. You're well within time. Around 30 seconds were still left. That's okay. I especially like the video sync and the presentation, At the end, I felt like, cheering, It was like exactly on sync. Job very well done. We'll move on to the question and answer session, okay?
Thank you so much, sir.
Jury, Alok, we'll start with you.
So, I was still looking for the headline about whether the project got net zero or not in terms of energy. That wasn't evident to me from your slides.
Sir, in terms of energy, the project got net positive. As I said, that we have the potential to generate about 1.5 times more energy than which is required for an annual energy consumption.
Okay. Okay. I'll pass it on and maybe I'll come back.
Sure. Yeah, I think a good job, well taken through at each level, especially the design of the unit, which is, I think, normally when we look at construction work housing, we talk about more like barracks, putting them together in kind of in a line and in a way that you've given individual units. I think that was the first plus point. What happens is that it's a home. It becomes a home. It's no longer a hostel or a dormitory. So that, I think, was a very smart move. And then in terms of viability, also it's easy because you can actually have this one module 10 times or 20 times or 50 times, depending on where it's required. So you don't have to kind of cut the barrack in pieces. So in a way, and personalization. One of the most important things I think we all forget is that these people are humans. They're, as much as they're working on this side, they also have some way to personalize their space. This unit allows them that somebody can have their little vegetable garden. Somebody may hang a small jhula. Somebody may actually, like you actually shown, open a shop. All kinds of things will happen over a period of a year or a year two. Within this layout, each will have a character. Somebody may even paint their veranda in a different way. So I think I think that to me came across very well as an idea. But it hasn't been taken forward, and I wish that was taken forward and shown why the unit was chosen why this particular simple unit was chosen, which otherwise would look like any other shack. I think what you need to do is to take it to that level of saying how this thing can be much more than simply a shack. It's a home.
Yes, sir, definitely, sir. It is a home away from home for the construction workers, as they live in project site for around 1.5 years or 2 years, depending on the duration of the project.
True.
So,
yeah,
I think,
so
sir,
keep that in mind, like
yes,
they
sir.
could actually have a garden, things like that.
Yes, sir.
The other important things that one wants to talk about is, when I'm just kind of referring to some of the notes, like the layout. When you make the layout, you just repeated them. I think it's important to also see why can't the verandas face each other? Each one faces a back to the other. So you would have reduced a whole road if you were to do that. It was smart that you've done the south side slope more than the north side. It's important. That is also important to note that the slope is not exactly equal on both sides.
Yes, sir.
North is lesser, south is more, which means you can get more power, more solar. So I think those are things important. But I think the layout as unit overall in the site, as much as it was smart in terms of the organization, I think it could have been a little more sensitive to interactions of human beings, and you could have reduced a whole road because the one of them road would have been a common road for both.
Yes, sir.
Yeah.
Yes.
Similarly, the MEP, especially the detail MEP, in your costing, the MEP is not mentioned. You mentioned the panel, you mentioned all kinds of things, and because that I think would be quite a cost, and you may want to kind of just relook at that cost because you haven't calculated that in your overall.
So we do have calculated in the cost estimation table provided by HDI. So, sir, when we were calculating, we have used daily schedule of rates, and through that we calculated the length of each section which we will use, and the detailed table, sir, we have provided that in D4 document, and sir, we also got an option to upload it as Excel document in HDI.
This was put in this presentation. You did show us this?
No, sir.
Okay. Yeah, I think as of now, I'll pass this to Manjunath.
Can you just take this slide of the cross section, the structure cross section? I'm just looking at
This one?
Yeah, just the foundation and all. I think you are talking about. I don't know. You said that this whole thing has to be erected in 15 minutes. Something I note.
15 days, sir.
Oh, 15 days. I think somebody's. I heard 15 minutes.
So it must be a
Huh? So I thought it's wonderful, no? That a guy can, create its magic, one. Second thing, I really don't know, what is are you resting this on ground, or why you are layering brickwork below the plate? Why the brick has to be on the ground? What is brick doing below the plate?
Sir, to ensure leveling, we have first made a brick base
How does the load transfer?
Sir, firstly, we have marked our places where we have to place the bricks. The bricks will provide a even base for placing the plate, because sir, if we will place the plate directly, it is prone to rusting also, and sir, it may sink also in the mud.
What is PCC?
Sir, bricks, sir, we can take back after dismantling of module, but PCC we cannot take back.
So then why do you choose any other material which can be easily taken? So finally this has to stand, right?
Yes, sir.
A structure has to transfer the load onto the ground. It's not that how using brick is something which I can take it is not the question here. Structurally, how it is feasible to transfer the load. How does the total load of the structure goes onto the plate and finally goes to the ground? That is the basic necessity, right?
Yes, sir.
Second thing is, a building of this volume of surface, what will happen if the building is lifted by wind?
Sir, the building itself weighs 1.3 tons, like 1300 kgs, because the weight of the solar panel is 22 kgs per solar panel.
I'm just talking about in terms of weight to the surface area, okay?
Yes.
Without any counterweight, okay? So how does this building balances against wind?
Sir, like we discussed with our faculty members of Civil Engineering Department, Dr. B.K. Singh at DIT University. So, sir, they explained us that the self-weight of the building, 1.3 ton, is enough to resist the building from wind. And, sir, through STAD and some softwares which the Civil Engineering Department uses, they simulated also that the building will not go away with the wind.
So this building is basically supported on the ground?
Yes, sir.
Without any anchor?
Yes, sir.
Then why do you require such a big plate?
Sir, because the weight of the columns and the trusses and sir, flooring also. Sir, it is so much that if we will not give the plate, the rectangular section will go inside.
Yeah, anyway, you have answer for every question for that matter. So what I'm saying is, why is the channel used in the wrong direction?
Sir, channels are used invertedly, because if we will use them upright, the water will fill inside them.
Why? What is the purpose of a channel? A channel has a depth and a width, okay?
Yes,
so since it is a bending member, you have put it on the weaker axis. It's not the question of how this has to be placed independent of the structure, okay? This finally has to transfer the load, correct?
Yes, sir.
But I think it's not about the shape of the channel which basically dictates that. It's not about that. You can choose a section which is not a channel. It can be a box section for that matter. Okay, and then these connection details are not very clear. When you take a section which is 1:20 scale, why are the dimensions are not given? Like if I'm looking at the purlin, and then you look at the plate, so these are very clear informations that dimensions have to be given.
Yes, sir. Surely, sir. We will incorporate that.
When you look at the a scale detailed T at such a close interval, why dimensions are not given? Okay, I'm talking about the channel and the angle, and the angle may not be sufficient for the flooring, and I'm talking about the plate just resting on the brick, Okay, and then there's a mortar which is so weak, how do you make the mortar level, is it, you understood, you can't
Yes,
use
sir,
a
yes.
mortar there, you have to use a non-stick grout. But the doubt itself is the, the brickwork, 75 mm thick brickwork below the plate. Which
Surely,
is-
sir. We will
which is-
reconsider that.
Okay, yeah, thanks.
Thank you so much.
So, I want to echo what Surya said about the, habitable, livable unit, because it's actually, for a period of 18 months or more, it is home, whether you call it home, away from home. And to that end, I think that, again, like the layout, because even if we want to have like the solar panels on the south and the north light, you can still flip some units around and create some very interesting interstitial spaces. There was so much potential in the layout, but we just went with create a good living unit, but then kind of we ran out of imagination with the layout, I thought. So just an observation. You also mentioned a B 5-star rating for
Yes, sir.
for what building type? I don't think there was a B 5-star rating for construction worker housing.
Sir, there is B 5-star rating for construction worker housing. They have listed their EPIs from ranging from 17 to around 55. So from that document, we have found out that we are lying in the 5-star rating category.
Okay. All right. I think like this is part of the sensitivity kind of thing, but on just the one sheet I saw, I think it was your first layout or the site plan sheet that said labor hutment. And I just feel like we need to be a lot more sensitive about the words we use. So that just kind of stuck out at me. Just wanted to kind of point that out.
So I just want to add a point. For the layout, we didn't face the dwelling units facing each other. In case of the privacy, we wanted to keep the indoor spaces more private, and we have given the common community spaces where they can interact and have a conversation. But for the commercial viability and privacy, we have oriented the units like this specifically, so that they don't face to each other.
This notion of privacy is something that comes, I don't know if you met these people ever, and their notions of privacy and our notions of privacy. I think it also, it looks, even though it's not a barrack, the layout makes it look like a barrack.
Okay.
So you had a huge potential. You got a veranda, you got spaces in between houses, you got everything. You got everything to make this a home. And that, in fact, the other thing is also missing is the layout. If you look at inside the bed, the way the bed is placed, it's like our homes, where you have a bed and you have two side teapoys, kind of side things. Do you think they will actually ever live like that? So the other thing is, how do we make a layout inside? I don't think this was part of the challenge, but I'm just saying, since you drew it, I'm just pointing it out. It's how would they live in these spaces? I think the drawing, the way you actually, this kind of enumeration would actually create a far more humanized potential. I'm not asking you for a reply. So don't worry. You don't have to reply to each and every of our questions. Some of these things are just suggestions. Yes. Yeah. And did you talk about rainwater much? Yes. In terms of quantum.
So this is our sedimentation tank. The drains from the site. These are the dotted line shows the drains on the site, which takes the storm water from this and to the sedimentation tank. And from the sedimentation tank, the water will be stored in rainwater harvesting tank, which is of 6,000 liters.
No, so that water is the road water.
Yes, sir.
What about the roof water? Is there a separation? So are you using the road water for some particular purpose and the rainwater from the roof for some other purpose?
We have also calculated the catchment area for roof, hardscape areas, and softscape areas.
Yeah.
Yeah.
But what you need to do is the separation of the collection. It's not just the quantum, it is the separation of the two, which is the road water would be used for agriculture or for even toilets, whereas the roof water would be used for maybe drinking. So that separation you may need to do in this detail. Yeah?
Okay. Okay, sir.
Done? Thank you.
Okay. I was just curious. One thing that kind of befuddled my mind was how can you get negative embodied carbon with a material that is produced? I think in your embodied carbon calculations you showed a material with negative embodied carbon, and if it is a material that is extracted and produced and manufactured, how we can get to negative embodied carbon no matter what the math? It just kind of confused me. I could not understand that. So I don't know if you guys understood that.
So that was even a challenge for us because the table through which we were calculating this, sir, for plywood, it was showing negative embodied carbon, and through that we were calculating this. So we were getting it, like, sir, it absorbs the carbon emissions because somehow, sir, it is linked to the environment only. And, sir, we got the information from the Excel file itself. Yes, sir.
All right. Thank you. Thank you for comments, jury members. Thank you, Team Echo.
Thank you so much, sir.
So we're just going to take 5 minutes. Hello, so we're starting with our second presentation of the day. Second presentation is from Team Econic. Please join me on stage. So Team Econic have worked on an elevator corridor project in Kasturba Nagar, Bhopal, Madhya Pradesh, and their project partner is VKSC Project Limited. So Team Econic, I'll give you the instructions. You have 20 minutes to present your work to the jury. So at 15 minutes, I will raise my hand as well as I'll provide you a signal. That's at 15 minutes, okay? You will not have a 21st minute. So by 20 minutes, if you're not done, I will physically get up and stop you, okay? So after that, you'll have 10 minutes for a Q&A session with our jury. So please keep your answers direct and to the point, all right?
Esteemed members of the jury and everyone, welcome to our presentation on a project that embodies compassion, innovation, and sustainability. Today, we introduce you to our on-construction worker housing by Team Econic. So, imagine a world where every construction worker feels valued, respected, and provided with a home away from home. Yes, this is the vision that drives our team, and we are here to showcase our groundbreaking solution that revolutionizes the way we approach on-site construction workers' housing. Our team consists of dedicated individuals from engineering and architecture disciplines. Me being from civil engineering department, I am Aditi Shukla, and my co-presenters are Ronak Mittal, Shiksha Goswami, Shyam Agrawal, and they are from architecture discipline. Together we bring wealth and expertise to our project. Our team is privileged to have the guidance of two distinguished faculty members, Professor Vicky Lal Ram Sanghi and Dr. Anupama Sharma. Their expertise and guidance is invaluable to our project. We acknowledge our college Maulana Azad National Institute of Technology, Bhopal, for nurturing our growth and learning. Moving on to the next is the design management process of our project. Our project includes site exploration, discussion with the project partner, building materials, heating and cooling strategies, achieving alignment between design proposals and digital simulation, finding case studies and studying them, and finally drafting a report. Our project is a collaboration between Team Econic and VKS Group. It is a leading project group in Bhopal, Madhya Pradesh, and having experience of 7 decades. Together, we aim to provide a better and comfortable lifestyle to on-site construction workers. But the current plight of the site construction workers is not good at all. No proper fenestrations are provided, and steel reinforcement are placed in front of the houses. No locking provisions are provided. No proper sanitary conditions are there. Algae formation can be seen near the housing facilities. All these are leading to extremely poor condition of the construction workers. The site location of the project is Kasturba Nagar, Bhopal, Madhya Pradesh. The total site area is 16,498.42 square meters with a total permissible built-up area of 3,150 square meters. It is in current ongoing development phase. When we discussed the project with the client came up with some special requirements, and they were childcare spaces, thermal comfort, healthcare services, hygiene, lighting, and ventilation. Also, when discussing the project with the project partner came, some issues were discussed, and these were the following requirements which came. Affordability, recyclable, low transportation cost, low wastage of water, low maintenance cost, ease of installation, proper water management, durable, and quality shelter. The site is a home to diverse group of laborers, including both skilled and unskilled. They are of various age groups, and they are working 8 hours each day, with being 120 people from age group of 21 to 40, 20 people from age group of 40 to 50, and 20 people from the age group of 50 to 60. Our goals include energy conservation, water performance, resilience, affordability, value proposition, architectural design, engineering and operation, together giving us the role to prioritize sustainability, efficiency and environmental responsibility of the project.
Now talking about the design part. Now let us start first with the design concept. So we want to build an accommodation for the workers that is more than just a row of sheds and include well-planned, hygienic and common areas. We have introduced central courtyard planning for the proper light and ventilation and introducing common areas for the gathering spaces which create a sense of belongingness among themselves. We have divided the spaces into public, semi-public and private areas according to requirements. For better understanding of the concept, we have tried to help the understand with the help of massing. So at first, we have created the mass according to the restricted site volume. And then we have divided the mass into two clusters, one for the families and another for the bachelors. And then we have introduced the service areas that is equally accessible from both types of clusters. And then we have introduced the central courtyard for proper light and ventilation and the gathering spaces. And at last, we have created the final product that is as per the requirements. We have introduced some of the passive design strategies as per the requirements. The first was the operable louvers were introduced for the natural daylight and the stake effect. Also, the upper flap of our unit was used for the rainwater collection. The rainwater collected is treated and used for the washroom purposes. And also, the bigger openings were intake for the natural daylight and ventilations. This was the detailed site plan we have explained here. The total site area was taken as 3,150 square meter as per the housing requirements. Services such as dining hall, kitchen, rainwater tanks, medical room, offices were provided as per the requirements. This was the 3D site plan we have explained for the proper understanding of how the units were placed. So these were the family units that were placed, and these were the bachelor's units that were placed. And in the middle part, we have the services such as dining area and the washrooms. And we have here the offices and the electrical room provided. Now moving on to the unit details. As we have discussed, we have two types of modules. One was for the family and another for the bachelors. Both types of modules are of same sizes, which is 4 meter by 5 meter, with the same structure details, with some minute changes in the furniture layout. We have the unit section explained here. We have a sloping roof with a height difference of 0.5 meter, where the louvers were installed for the stake effect. We have the electrical and the fire layout explained here. For electrical room, we have provided for electrical layout, we have provided an electrical room on site from where the distribution of the electricity is done. And here the unit electrical layout shown with the details of the fixtures. We have the site water supply and the drainage layout and the rainwater harvesting layout with the inlet and the outlet details of the structures, and also the location of the rainwater tank and the water storage tank. Now talking about the engineering and the operation part. So to make the design effective, it is important to have the structure stable. And to have the structure stable, it is important to have the right selection of the materials. So we have selected materials that is more stable and less carbon emitting. So talking about the base structure, we have introduced the tire foundation as our base structure. For superstructure, we have introduced the bamboo as our material. For joints, we have introduced stainless steel. For flooring, we have introduced fiber cement board. For roof, we have introduced corrugated bamboo sheets. And for walls, we have selected gypsum board with rock wool insulation. These were the joinery details explained. We tried to keep the joinery as simple so that it is easy to install for the workers. The first shows how the bamboos are joined at the corners. Second shows how wall panels are connected to tongue and groove joints, as they are of sizes 1 meter by 1 meter, so that it is easy to install and replaceable. The third shows the details of how fiber cement board is connected to the bamboos. And the fourth detail shows how wall panels are connected to the bamboo. Fifth shows the tire foundation details, and the sixth and seventh shows how doors and windows are installed in the unit. Now, moving on to the structure details. So to better analyze the structure, we have done the analysis with the help of the StratPro software, and we got the result for the how much depth we have to provide for the bamboos and other things. And these are the result for the load distribution, loads on foundations, deflection in the structure, shear and bending moment. So what we can conclude? So we can conclude that the unit is safe from the dead loads and possible live loads. Now moving on to the unit installation process. So we have provided a step-by-step procedure for the unit installation. The first step is the laying of the foundation, that is the tire foundation. Then the installation of the superstructure, that is from the bamboo materials. Then the step 3 is the installation of the floor panels. Then the installation of the wall panels. And at last, the installation of the doors, windows, and the roof. Now talking about the innovation part. So at first, we have introduced the biogas system, which aids in the disposal of human waste in a 100% eco-friendly approach. This technique produces colorless, odorless, and combustible biogas that can be used for the cooking purposes. Next, we have introduced a tire foundation in our design, which is a low-tech solution, which is composed only of scrap materials, and this foundation can reduce the effect of seismic vibration on the structure. Next, we have the root zone treatment. It encompasses the interactions of the various species of bacteria. And then we have introduced eco-coolers for our design, which can be installed in our unit with the help of the drilling, and helps in reducing the temperature inside the unit. Next, we have the UDT toilets. These are the urine diversion dry toilets that can be used as an alternative to the pit latrines, as they are easy to install, maintain, and can be replaceable easily. And they do not smell much, as there was an issue with the pit latrines. And at last, we have introduced the wall panels, which is made using the gypsum board installed on both sides of the rock wool insulation, which helps in maintaining the temperature inside the unit. Now next, Shyam will continue.
We have done a comprehensive comparison of the materials used for walls, roofs, and floor based on the factors like cost, strength, U value, and thickness as mentioned in the table. For wall, we recommend a 50 mm of rock wool sandwich with two 12.5 mm of gypsum board, which enhance the heat gain time lag. For floor, fiber cement boards are recommended, and for roof, bamboo corrugated sheets were recommended. The bamboo structures offer numerous advantages. The purpose of using the bamboo structure here was like steel has a more embodied carbon emission compared to the bamboo, and bamboo and steel have a comparatively the same tensile strength. Coming to the sustainability and affordability, we have implemented use of urine diversion toilets, which are economical, easy to install, and reduce the water consumption. We have also implemented the use of tire foundation, which makes our module adjustable, earthquake resistance, and reusable. To maximize space and flexibility, we have used the multi-purpose furniture, which not only saves space but also lowers the cost. We have also implemented rainwater harvesting system, which provide us various benefits, such as reducing water bills, recharging groundwater, and preventing soil erosion. In the terms of, in the efforts of reduction of the energy consumption, we have yielded positive results. We have started with the baseline EPI of 27 kilowatt hour per square meter per year, and with the implementation of passive technologies such as climate responsive strategies, maximizing natural daylight and ventilation, we have achieved an EPI of 20.54 kilowatt hour per square meter per year. Further, this energy consumption is supported by the solar power production, with a solar power production of 89,060 kilowatt hour per year over an area of 195.2 meters square. We have achieved a net zero energy module, which means that the total energy consumption of 64,701 kilowatt hour per year is completely offset by the solar power production, leaving us 24,359 kilowatt hour per year of surplus energy. The EPI value of 20.54 kilowatt hour per meter square per year includes the safety factor and power losses of 1.5. If we remove this criteria, the EPI value becomes 12.79 kilowatt hour per meter square per year, which is a significant achievement. Our selection of passive techniques such as providing window coverings which blocks the summer sun radiation and allows the winter sun radiation to regulate proper heating and cooling of the module. Our selection of materials of high thermal insulating construction materials such as rock wool, smart low emittance glass for window coverings have greatly contributed in the reduction of energy consumption. Coming to the radiation analysis, our observation on the radiation analysis have concluded that the radiation analysis of the roof surface radiation value is consistent throughout the year. That is 135 to 200 kilowatt hour per meter square, which makes roof ideal for the placement of solar panel. Now coming to the daylight analysis, we have to optimize the natural light. We have optimized the daylight analysis. Here, the green area shows the areas which gains 300 lux of natural light for at least 50% of the day, which results in minimizing the use of artificial light in the daytime and saves the energy up to 50%. We have to ensure the sufficient illumination during the night time. We have also additionally installed LED lights in the areas where natural light is insufficient. These areas are depicted by the blue color in the plan. For the cooling purpose, we have implemented an innovative solution of terracotta jali. In summer, this jali can replace the module window and leverage the effect of venturi to cool down the hot air. Further, pouring water through the capillary action can enhance its efficiency, resulting in reduction of the energy consumption for cooling purpose and reduction of temperature from 4 to 6 degrees Celsius. Our design prioritized the embodied carbon through the construction material. We have carefully selected the construction material which has lower GWP, that is global warming potential, ensuring that they maintain their strength, fire resistance, and durability, and more. We have also compared including emissions from the wall, roof, floor, fenestration, and structure, and successfully reduced the carbon emission by 50% compared to the baseline design. That is from 62 kg CO2 in baseline to proposed 32 kg CO2. We have, for ensuring the indoor air quality, we have also used the oxygen bomber plants as mentioned in the table here. The oxygen bomber plants are plants which emits more oxygen and absorb gases like carbon dioxide, carbon monoxide, benzene, and more.
For a net zero water performance, the shown water cycle has been used. 3 systems, rainwater harvesting, root zone system, and biogas system are incorporated, at the end of which we get fuel, which is used for cooking, and nutrients-rich water, which can be used as fertilizers. According to the standards, baseline water consumption for domestic purpose is 135 LPCD, but we are able to reduce it to 95 LPCD through the usage of UDDTs. Now the pie chart here shows the water distribution among daily activities of workers. The graph here shows the generated grey water, filtered grey water, and stored grey water. The root zone system, the efficiency of root zone system is 75%. That is, 75% of the total grey water generated is being filtered and stored. And for the storage of that filtered grey water, we have provided an underground storage tank with a capacity of 9 cubic meters. For utilization of rainwater, we have incorporated rainwater system. And for that, we have, the graph shows the harvested rainwater and the occupants' monthly demand. For rainwater harvesting, for the harvested rainwater, we have provided 2 water tanks at 2 corners of the site so that it has well connectivity to all the units. The table here shows the occupants' monthly water demand. That is, daily average water demand is 16,150 liters, which we are able to reduce to 4,252.1 liters per capita per day. The storage tank is provided for the same storage of water. Keeping in mind the wastage of water through fixtures, we have provided faucet aerators and shower heads with an efficiency of 80% and 60% respectively, which reduces the wastage of water up to 50 to 70%. For resilience, at first the identification of disasters were done. Disasters like drought, floods, heat waves, and other hazards like pandemic are most likely to happen in our site. So for that, autonomy for some critical functions like food supplies, medical supplies, water demand, and energy supplies are provided here. Other impacts of disasters were also analyzed and their respective mitigation measures were taken. The table here shows the impacts like fire, temperature uncomfortability, and rupture of water pipes. Now the steps taken for recovery after this disaster hits are need of medical facilities on site, transportation to the nearby hospitals as soon as possible, replenishment of all the reserves, replacing and recovering components due to structural damages, and dismantling of modules and resettlement of people to other open areas. Now at last, I would like to summarize the attributes of our modules that is easy to assemble, adaptable to different weather and terrain conditions, affordable, cost savings, proximity to job areas, job sites, comfortable living and thermal conditions, increased productivity of labor, and safety and security from outside environment. Now, we, Team Iconic, would like to thank you for providing us the opportunity so that we can present our net zero design solution in the form of Project Agar.
All right, Team Iconic, well done. Thank you for the presentation. We'll move on to the Q&A session with the jury.
Hi, thank you. Well presented. First, one credit is that a lot of the presentation you were anchoring yourself into we've done this, and you've shown a lot of graphics continuously for each and every that right from the. I think the point here would be to show how you've done it. You've done it all. Fine. It's very nice that you've done it all. What you want to really talk to us is how you've done it. What are the various details, each and everything. So I'll just start with one thing. I think the larger layout, when you look at the roofs, it's quite a large layout. But when you put it as solar, the slopes of the roofs are all different, in different directions. They are somewhere south, somewhere north, somewhere east, because the layout the way you planned it. And you're showing that as solar, so that you may want to kind of rethink the slopes of your roofs in a way that they're more efficiently using based on the latitude requirements. So that's one. Yeah, you want to answer that?
Yes, sir. Sir, in the site plan, we have shown that the solar panels are only placed on the these canteen units, dining units, which are sloping towards south.
But you claimed something else towards the end. There is one whole slide where you're claiming excess solar power generated, which you're going to give back to the grid. That there's one yellow kind of thing.
Yes, the same solar power is generated. All the solar power, that is 195.2 meter squares of area, is all placed on these dining units.
To the one where you actually claim.
There in the section we have shown the solar panel. Just I will take to that part.
Yeah, this one.
Yeah, this one. Here we have shown the solar
back. Yeah, here you're writing total energy generation through solar power is 89,000 kilowatt per year, over distributed to
42 housing modules.
It's not. This 195 is only the.
Yes, sir. Only on the roof of the dining hall.
Okay. I thought that was so. That's all right then. Yes. The other thing is the detailing regarding the joinery between, especially the wall panel, gypsum. You've used gypsum as a wall panel. You're probably just looking at U values, but you have to also look at maintenance. You're also talking of reusing these, and you got these gypsum panels as walls, whereas they may be very efficient in terms of U value, but you also have to look at 10 times or 15 times, whatever your designated number of times that you want to use it, whether it's really an efficient way. A, B, water. This is also going to be in rain, and it's finally a little soft compared to many other materials. And whether it will last given the kind of conditions that it will be used in. So you may want to think about it. Other than a U value, there are other characteristics.
Sir. So you have thought about it. So the first question you have asked, like for the maintenance purpose. So for that we have made the wall panels of 1 meter by 1 meter. So it is easy to maintain, replaceable if in case it is damaged or something. So we have made in such a way that the full board doesn't destroy it, and only the 1 meter by 1 meter panels can be changed and exchangeable. And for the second question you have asked, like at the time of the at the time of rainy seasons, so we have the processed gypsum board that can be used, the waterproof gypsum board that are available. So we have used and that.
You must remember, when they say waterproof, it doesn't mean continuous rain.
Yeah.
So I think you must investigate waterproof, versus simply an iron tin sheet. So there would be a huge difference. Yeah. The jali. One would want to understand a little more about how you intend to. You're claiming 4 to 5 degrees. You have to show these tests. If you're saying that you're actually going to do this, you have had enough time, because you've been claiming this from some time, quite some time, in your presentations, earlier presentations also. By now, at some point, you have to then make it, put it, meter it, and say, yes, it is 5 to 6 degrees less. So without it, you can't just say, on what basis do you say it's 5 to 6? I can say 20. On what basis? So that's it. It will not be accepted without a test. B. And second, how do you see water actually being poured? What is the detail of how the water actually is poured onto it? What kind of water? Where does the extra water go? I mean, you understand that whole detail of that cycle. Otherwise, these are all, as of now, still imaginary, but potential hai. But then it needs those steps. Yeah. So I'll take. You can go ahead and answer, please.
Sir, in this, we have here are the gaps, as you can see. We have introduced there the sponge. Okay. Then we have at the bottom the tank. So through the capillary action, this sponge will absorb the water, and this terracotta jali. So earth is good in the absorbing of water. So from sponge this will absorb, and the excess water, there is no wastage. So it should go. The sponge will hold down, and it is a evaporative cooling. So yeah.
The concept, you have to test it in the sense, what is the density of the sponge? Will the water, when poured, will it go straight down? What is the way the water will stop, and then it will stop at every level that the terracotta piece has to kind of, because the water by gravity will tend to go down. So it's far more complex than a drawing. So it's an idea to start with, but then you got to test it out. Yeah, I'll
Yes,
pass
sure.
the mic to.
So I think in continuation with the structure, if you can put the slide of the structure.
Yes, sir. So the analysis part?
No, not the analysis. In this, I think just very simple to me is, you looked at bamboo as a pipe, okay?
Yes.
But the details which come to pipe is not the same as for bamboo. Bamboo is not seamless like a pipe. Bamboo has varying diameters, but the junctions what you have created for this, the 90 degrees, you look at this second sketch, second photo, the detail at the corner, how can the plate be bent like that to a profile where it receives 4 bamboos at a time?
These are available in the markets, this type of joints.
No, but I've not seen these joints anyway. So these are, second thing is, you see this clip which is connected to the bamboo as a wall panel,
Yeah,
So how does this clip gets attached to the bamboo? The bamboo has varying surfaces.
Yes.
How does
As shown in the figure, sir, you can easily see that this SS strips which are attached to the wall panels is attached to the one strip that is connected through this nut and bolt.
Okay.
So we have connected all these 3 strips which are connected to wall panels are connected to one. So 2 to 3 will be installed in that 3 meter.
So the
span.
gap between the plate, which is almost linear, and
Yeah,
the undulation of how do you seal it?
Sir, can you repeat it?
The gap between the bamboo
Bamboo, yeah.
and the edge of the panel
Yes.
clamp, you'll have undulations. No, there'll be a lot of gap. So how do we seal all these things? I just want to say is, can we look at bamboo, which is natural, independent of this wall system, so that you don't end up in all these, difficult areas of sealing. If the bamboo is independent of the whole surface, so you don't need to worry about all this marriage between these 2 elements, one. Second thing, the same thing with in relation to the roof and the floor, the elements which you have looked at, members which are supporting, they are all uniform, one size member, one member. So how does the bending happens? How does the undulation of the bamboo and the surface? These are things which are, how do you fix these things, which is very difficult to handle? So should we make it independent of this system, or if you make it in line with the same system, then it becomes a problem. If I'm using a pipe, you can work out a detail to connect all these panels. but still it is a difficulty. So I was just looking at this whole, joinery detail. I think it doesn't make any sense to me. Yeah, the skin and the structure, and skin being natural, and you can't get even surface anyway. It's not a pipe, no? It may look like a pipe, but it's not a pipe. Right? Yeah, that's it, yeah. From me.
Yeah, so first of all, I think for the guys on the team, this is the best dressed team in the room. So we need to acknowledge that they are at least dressed to win. So looking sharp, I like it. I think, so I have a few thoughts that came to my mind. It was not very clear to me where the eco coolers were being used in your, form. From some of the renderings. I tried looking at it a couple of times. It was also not clear what you were achieving in terms of load reduction through passive measures. I think that there was some good, there was some calculation, but through passive measures that was not kind of clear, and how you arrived at the reduction in EPI. You mentioned that it's operational. They're on site 10 a.m. to 6 p.m. and they're using using the unit 7 p.m. to 5 a.m. So I'm wondering what they do from 5 a.m. to 10 a.m. It's just, as I looked at your operational hours for the units, I was just wondering that, how that happened. You also had, I think, on one of your value proposition slides, you mentioned increased productivity. And I was wondering what you might have kind of, figured out in terms of the increased productivity claim. So those were some of my thoughts.
Sir, by saying that increased productivity, we are meaning that since the workers are being comfortable and they are resting more, so their productivity on site will be increased. And so it will help in their occupation as well.
Also, sir, you have mentioned about the placement of the eco coolers. Yes, it is not shown in the slides, as we had to make this slide limited so that we can complete our presentation in 20 minutes. But yes, we have told in our presentation that it will be replace the module window, or it can be screwed to the module window. We have that both facility.
Okay, but the window has more than a function of just the ventilation, right? I mean, it's also a connection to the outdoors and the view and that. So if you replace the window with this, then you're shutting the view and daylight and...
Yes, but daylight, and for that we have used the this louvers that is placed on the sloping part, that on the extra this heighted wall. Also, if this is placed, then it is after a jolly, sorry, we can just have some of view on the outside. But like if we thought to place another things, but although it is coming on the windows only because it is a natural means of cooling. That's why.
Okay. I also am, just kind of, as I see the mention of biogas and root zone treatment in innovation, I'm not really convinced that it's very innovative. I think this has been around. So just kind of, stating that as an observation. Yeah, I would have liked to see the eco cooler being actually integrated into the architectural expression. Yeah, I think that's it from me.
Thank you very much, jury members. Thank you, Team Iconic. So we'll be taking a small 15-minute break before we begin with the third team. Tea will be served right outside the hall. Online folks, I request you to stay tuned and be with us to support the teams that are going to come up. See you soon. She's my boss now. All right. Welcome back to presentations for the on-site construction worker housing division. Okay. So our third presentation is by team Angra. So they have worked on a construction worker housing for the INS Varsha. INS Varsha, right? Yes. Under Project Varsha for the Indian Navy at Rambilli at Vishakhapatnam. And the project partner is Kamani Engineering Corporation International Limited. Please join me on stage. Okay, so I'll just provide the instructions once more. So team, you have 20 minutes to present your presentations. At 15 minutes, I will ring a bell and also raise my hand to let you know that you have 5 more minutes left. You will not get a 21st minute under any circumstance. I will definitely get up and stop you wherever you are at the after the 20th minute. So once you're done with this, we'll go for a 10-minute Q&A session with the jury, okay? All the best. I'll let you know when to begin.
Greetings. As important as the other divisions in the competition are, all of them rely on construction workers to ensure their fulfillment. And hence, all divisions serve as a premise for construction worker housing. So, we chose this division because it impacts the lives of people who are the backbone of the construction industry. Yet, when it comes to housing them, all they get is neglect, lack of regulation and codes, unhygienic living conditions. Their living quarters are cramped, often structurally unstable, and have poor lighting and ventilation indoors. Team Angra takes a data-driven approach to ensure sustainability, comfort, and good living conditions for the workers. In the process, we have formed an interdependent proposal which looks at all aspects of the problem while ensuring peer learning and increased working efficiency. Our project partner is KEC International, which has taken up the INS Varsha project by Indian Navy. Team Angra has designed the construction worker housing colony for the same in Rambilli in Andhra Pradesh for an occupancy of 210 people with opportunity to expand to 700. The site is located in a warm, humid climate, and the proximity to the sea also affects the microclimate on site due to sea breeze. The prevailing wind direction primary is from the southwest, while the secondary prevailing wind direction is from the north. The site area is 8,270 square meters, while the built-up area is 2,400 square meters.
Some of the important milestones that we've achieved in this project are net zero water performance and 100% fulfillment of demand in conjunction with reducing water consumption and also having 3 days worth of water storage on site. We've achieved a net EPI of 9.762 kilowatt hour per square meter per year with the use of efficient fixtures, passive strategies, and on-site generation. Reduction in per square meter cost of construction by approximately 60% as compared to the base case. Looking at the current site conditions, digging a borewell is not feasible due to the salinity of the water, and there's a lack to the grid connection, and thus we are relying completely on tankers. Basic necessities like drinking and cooking have been adhered to the WHO standards, and the reduction has been done using efficient fixtures like aerator taps, non-water urinals, and flushes, and also accommodating to the current lifestyle characteristics of the workers, thus reducing their consumption from 138 liters per day to 57 liters per day. We have integrated differentiated treated system based on the waste generation. The grey water is used for flushing and non-contact activities after it is treated through the biochar system, which is modular, easy to install, and low on maintenance. The black water is fed through the biodigester system, in which the solid matter is converted into biogas, which is used for cooking, and the liquid effluent is fed through the reed beds and led to the ground. This system also does not require any additional energy and is low on initial and operational costs. The rainwater is collected both from roofs and hardscapes and softscapes, and they are separated in case any treatment is required. Softener is added because of the acidic nature of rain and also due to the salt accumulation on the roof due to the sea breeze. And on site, we have 3 days worth of water consumption, that is 50 cubic meter of water stored on site. And the excess water that is collected during the rainy seasons is given to the construction site for storage and then taken back during the dry months.
When it comes to the energy consumption, for the base case, the base case is lower as compared to the proposed case as they've used minimal fixtures. But then we also generate energy on site, which helps us achieve the EPI. When it comes to the reduction in the base case, we've used generation on site, we've used passive design and thermal installation, and also used efficient fixtures. This brings down the EPI from 25 kilowatt hour per square meter per year to 9.76 kilowatt hour per square meter per year, which is almost a 60.96% reduction. Now we come to the modes of operation. We have 3 modes of operation. 1 is normal, under which all systems are running. 2, which is critical, under which non-essential systems are switched off. And 3, which is autonomous, only where basic systems are running. The battery provided is in such a way that only critical energy is saved only for the critical storage for 2 days worth of autonomy. And when it comes to the service fixtures and service lines, we have made it in such a way that all the fixtures are connected in 5 lines, and each of them are further distributed to places like common areas, kitchens, clusters, etc. When it comes to affordability, the total budget stands at 1.5 crores. The project partner has built 1,000 square meters, whereas we propose to build 2,400 square meters. We have also used, due to this, there's a reduction in the percentage by 60.96% in the cost per square meter. And also we've tried to use the reduction in such a way that we have also tried to use critical analysis for costing of systems such as solar panels and wastewater treatment systems. Even though we could achieve a net EPI of 0, we still did not go for that because of budget constraints and have stuck to using 215 solar panels, which is 430 square meters of area. When it comes to the biodigester used, we have spoken about earlier during water performance as to why it's more efficient and when it comes to both costs and water. In comparison to market rates, we've taken 3 scenarios. 1 is the prefabricated units by the project partner. 1 is the market available containers, and the last one being our unit. That's why, influenced by these numbers, we plan to rent out these models of 8 units with 3 accompanying toilets. This was influenced, and also the numbers regarding these are that we have a return on investment of 62.19%, a break-even at 1.89 years, and a payback period of 2.36 years.
Coming to the area program, this was devised from the project partner information, and we have devised the entire area. Through this, we have achieved successful housing number of people while maintaining overall physical, mental, and social well-being of the occupants. We have achieved 100% of comfort hours using passive design strategy. We have ensured that we have electrical autonomy for 2 days, making our structure resilient.
Coming to design, when we started off with the design, we had certain principles in mind. Firstly, using permeable walls to ensure no dead zones inside the rooms. Then louvers for both sun shading as well as ventilation. Then buffer spaces around the clusters as well as uses of courtyard and interaction spaces to ensure adequate comfort for the users. Each unit is a 4x4 meter in plan and houses 3 people in it. This means we have provided 5.33 meters square per person, which is conducive with the equivalent codes of hostel accommodation in NBC. The louvers are strategically placed to provide adequate indoor comfort, while the unit on the ground floor and first floor act as an independent structural unit with the columns made of steel and walls made of Angra panels. 72 such units are arranged around a courtyard and to provide space for interaction, and 4 such clusters are arranged on site. The clustering is done keeping in mind the comfort and circulation considerations of the users while maintaining structural efficiency. The toilets are designed based on the NBC requirements for the hostel accommodation and are divided into 2 blocks for ease of access. The kitchen, dining, and the common room are places where the construction workers interact, and in their character they differ from the units as they use mud compacted plinths and bamboo wall panels, which provide a setting similar to the village houses these construction workers hail from. The outdoor recreational area is a place, is designed in between trees in the common area courtyard, and it is a place where the workers can engage in recreational and cultural activities to build a resilient community together.
A well-equipped first aid room has been provided in the common area, which caters to the health of the workers. It can also act as an isolation ward in case of communicable diseases and as a quick medical response before transferring them to the nearest hospital. According to our calculations, the total number of occupied hours are 5,475 hours, that is 15 hours per day. Out of this, 63%, that is 3,687 hours, fall within the comfort band according to the adaptive comfort model. The 759 hours, which are in the discomfort band during the summer months, have an indoor operative temperature of 30 degrees Celsius and can be brought to the comfort band with the use of ceiling fans. The wind simulation shows that the sizing and placement of windows plays an important role in achieving the 100% comfort. Placement of clusters and permeable walls has helped us achieve an internal wind velocity of 1.2 to 3.05 meters per second. We have 3 kinds of fenestrations: louvered screens, clerestory openings, and glazed windows. The shading devices have been designed according to the orientation, and they're all clippable.
When it comes to resilience, threats were identified using the BMTEC map and
Coming to the next important part, engineering and operations. The project uses a multifaceted palette of materials, including recycled, natural, reused, and newly manufactured materials. The project rests on a foundation. The project rests on a foundation of tires, which is underground, and it's filled with rubble in order to stabilize it. J-bolts and mild steel plates are used to connect the foundation to the I-beam columns. Box section columns. The I-beams support the floor above, and intermediate T-sections are used to fix the walls and the floors to the structural system. The sizing of the structural system is done based on flushing the structure to the wall panel. A walkway is fitted on the ground floor to ensure workability, and the same process is repeated for the first floor, creating the whole unit. The roof of the structure is made of a bamboo truss, and the solar panels is fixed onto it. Using this simple and systematic structural system, we have been able to achieve an 10-hour assembly time while 8-hour disassembly time with 6 people as workforce for one unit, which is ground floor and first floor. The project uses a frame and internal panel system for its structural joineries, and the joineries are kept modular, repetitive, yet simple, in order to ensure easy assembly and disassembly while with minimum supervision on site. Coming to the services, the wiring in the rooms happen between the sandwich floor panels to ensure a clean appearance. In the toilets, there are 2 layers of services, one through the ceiling for the wiring for the lights and pipes for the water, and one through the floor, which takes the sewage and the sullage. Coming to the master plan, there are 4 important service lines. One is the electrical, which starts at the HT yard and is connected to the various zones. One where the water is supplied from the holding tanks north to the kitchen to the toilet units through gravity flow. The rainwater is collected from the rooftops and the hardscape south of the common room and pumped through 2-stage pumping into the holding tanks. And fourth, the biogas, which is generated in the toilet units, is sent to the kitchens and fit into a holding tank through a pressurizer.
Our innovation, the Angra panel, is made to balance affordability, ease of construction, and embodied carbon. Our industry partner, Ricron India, has helped give the theoretical values and information regarding their product. We use a sandwich panel of 5 mm thick Ricron sheets as fascias and having 10 mm corrugated jute mats in the middle as a core material. The exploration of this was done using a grasshopper code, which was further authenticated by us by making a prototype. While making the prototype, we tried to use jute, but the same volume of jute in the form of rolls and with air gaps to ensure that the same volume of jute is used in both places. And for the calculations, we made an enclosure, and then we placed a thermometer inside and outside and measured temperatures at equal intervals. And the values were calculated, and we had a theoretical U value of 0.25 watt per square meter Kelvin, whereas our tested U value is 0.25 watt per square meter Kelvin. We've also done water, fire, and UV exposure tests, which all yielded satisfactory results.
Throughout the project, we've used natural and recycled material like Ricron, coconut wood, bamboo, etc., which have helped us achieve a reasonable embodied carbon of 159.1 kg CO2 equivalent. For the method of calculation, we have referred to the inventory of carbon and energy by the BSRIA guide. This reduction has been possible by reducing in different elements like the roof, the wall, fenestration, floor, and structure. The use of Angra panels instead of the market-available ACP panels has allowed us to achieve this. Angra panel also has a lower U value while being comparable in cost and having 70 to 85% lesser embodied carbon.
Why should
All right. Team Angra there upping the game with physical prototype also. Okay. Thank you very much. On to the jury members for the Q&A session. We'll start with Manjunath this time.
Yeah, coming back on the structure, the tires, the plate, and the J boards. Can you just explain me on that junction?
Yes, sir. So basically the tires, so a pit is dug and then the tires are put inside the pit on a compacted earth base.
What tires are this?
They are
scooter tires or?
No, they are car tires where they can be reused.
Is there a specific of a diameter? Or
Yes, sir. It's the diameter of the
how
tires.
How do you base these tires? In the volume of dead weight, or what is the how do you choose the diameter of the tires?
Yes, sir. The diameter of the tires, one was chosen based on availability. Secondly,
yeah, but for our structure.
Yes, sir. Secondly, also based on the load distribution that is required, the area that is required to distribute
Correct.
the load.
How much is the load on the column as per your analysis?
So the total weight of one unit is around 22 tons.
Including 2 floors?
Both floors, divided into 4 columns. Okay. So that's around 5.5 tons.
Okay. What is the SBC of the soil?
The soil bearing capacity of the soil is...
At the depth of whatever you are placing it.
The soil bearing capacity that we have considered is the design minimum of 200 kgs per meter square. Because...
Something is wrong. No? Okay. Anyway, just check on that units. Okay. Yeah. Now, this cross section, if I am looking at the J bolts, what is the purpose of these J bolts?
So basically, as I said, after the tires are placed, the rubble is filled in.
What is rubble?
Coarse aggregates, like rubble from any construction industry.
So it can be a brick also. It can be brick rubble.
It can be anything. The rubble just holds, gives it anchorage into the soil.
How does the anchor between the bolt and the rubble?
Yes, sir. So after the rubble is poured,
But you get anchorage?
Yes, sir. So we have to pour a 5% cement slurry, a minute amount, for the anchorage to happen.
So it is a rubble concrete.
Yes.
I don't know what 5% of cement.
Yes.
So in your cross section, the rubble goes into the tires, or it goes only in the hole?
No, it goes into the cavity of the tires.
Yeah, because it's not shown in your drawing. It shows empty.
Okay, sir.
The rubble is going through.
Yeah.
But I don't know whether you can actually see when there is a compression, the bolt doesn't have any meaning.
Yeah.
When there is tension, the bolt has meaning.
Yeah.
So if the bolt has to anchor into the motor, it has to develop that development, stress.
Yeah.
Do they get the development stress is what is important. And then second thing is the weight, which is the quantum of, material inside the, tire should achieve that weight.
Yes, sir.
Because this is not, basically it is not anchored totally, it's how much depth you are going into the ground?
800 mm depth.
800. That is something which you have to look at.
Okay.
And second thing is your basic detail, you are putting a decking concrete. What is that
so the
decking sheet? The corrugated Recon panel. What is the pitch of that and how much it is spanning?
The supporting intermediate support members.
The spacing between
the spacing between them is 900 mm center to center, and they go transverse. Like
what is the pitch of that? What is the pitch of this corrugation?
The height of the corrugation is 16 mm.
16 mm. What is the pitch between the trough or the rise?
The pitch between the trough and the rise. So the height is 16 mm and the width is 150.
16 is too less. What is the thickness of the Recron panel itself?
8 mm, sir.
8 mm.
Yeah.
8 mm means if it is 8 mm, if the corrugation is 16 mm, there is nothing, just bent by one more thickness, right, to achieve
Yeah.
16 mm. So that's one. Second thing is how much of load you have taken for this floor? What is the live load?
The live load taken is 4 kgs per meter square.
400
Go
kg.
4 newton per
Your,
meter
your,
square.
your units are going
Yeah,
way,
sorry,
you know.
4 newtons per meter
Yeah,
square.
as per IS is 200 kgs per square meters for residential.
Yeah.
You're designed for a heavier load, for 400 commercial loading. Just check on the loading,
Yes, sir.
basically, because to be, it's very simple, what you have looked at is very simple. The live load, which is not more than 200 kg per square meters, and I think what we need to look at is basic connection, either it is I section, how the I section gets connected, the simple arrangement of cleat, then secondary members, decking sheet or whatever sheet you have proposed, and what is that you are filling it above the sheet to make it horizontal.
So that is straw bale.
Huh?
Straw.
You fill it with straw?
Yeah.
And then what is the flooring material? Is wood?
The same. No.
Same.
Same recron.
Acha. Okay. What is the total load you said?
The total weight of the unit is
Not total unit. You said some 20 tons, right?
20 tons. Yeah.
20 tons, including it's the dead weight or the live load, including live load?
It's the dead weight.
Okay. But the slope here is very less, for the bamboo. The slope for the roof, no?
So
What is preferred slope as per the codal provision for the bamboo? Because bamboo can't afford to have constant water depth of load.
Yeah.
It will stretch, the trough becomes horizontal, Okay, anyway, just look at it. Yeah,
Yes.
I'll just, thanks, yeah. This continues too much.
So I just made the remark about a sharply dressed team the last time, and Surya was telling me that this team has now color coordinated for the. So that's great. I mean, I do like the fact that you guys are putting some thought into the way you're presenting yourselves in addition to what you're presenting. So it needs to be said. I also think you guys did a very good job with the team roles and responsibilities. I think that whole seemingly complex spider chart of one person responsible and more than 2 people in the team. I would like to imagine that it would have made for a very rich experience with the design and the project collaboration. So I mean, as I saw this, I just kind of thought that, did it really work this way though?
Yes, sir.
Okay.
It did work.
Everybody did what they were supposed to do.
Yeah.
Okay. All right. Good. I saw something about like some 1% reduction with passive loads. I was scratching my head about that. I'm not sure.
So
Yeah, 1.3. Okay, it's 1.3 kilowatt hours with passive loads. Okay. I think you all did a very good job. I think a lot of analysis. I also liked your visual representation language in general in terms of what you did with the report. So far of all the presentations I've seen, I think you've done the most in terms of responding to the last round of comments. And that, to me, at least as I was looking at my comments and some of the responses, it seems like this of the teams we've seen so far at least looked at the comments. So I think that is reassuring, and whether that has done enough in terms of moving the needle, we'll see. So yeah.
Yeah, I think you guys had quite a challenging site. If you look at in terms of cyclone, specifically cyclone, you know that. Yeah, you know the last cyclone, the speed.
it was 175 kilometers an hour wind.
200 plus. Right here, Visakhapatnam, right? Yeah. So just letting you know, that's the kind of zone you're working on.
Yes, sir.
and we're looking at this material, and we're looking at this kind of structure, and we're looking at 2 floors on top of that. And obviously some of the questions that has already been asked in terms of anchoring become extremely important. So my first question is the idea of structure and panel. We find that when we do these things, especially when you're doing dismantleable and re-putting things together, the junctions between the structure and the panels are very crucial. They leak, water will come in. So whether you want to rethink that as separate, where this, so somebody's putting up the structure, the walls are being put up. Whether the rectilinearity, the perfect line and level and angle of the structure matters to the wall or not, also becomes extremely important. When you're actually dismantling and re-putting things back, it's very difficult to get perfectly plumb and line and levels. So as a system, you want to think, and you maybe want to think about that. Second, also, if there is a issue of the slope of the roof, maybe the solar panel itself, because the solar panel seems to have a different angle than the roof. So potentially, it wouldn't have needed an extra structure of itself if the roof itself had risen to that angle. Because of the rain in these parts can also be quite lashing, and you would need a lot of quick disposal of the water from the slope. So the slope of the roof, even from the consideration of rain, because the weight, especially the kind of roofing material that you're using, would need, cannot take too much load. The water needs to be really moved away fast. The floor, I have serious doubts. Yes, I must appreciate one thing, that you're one of the groups that has really done physical research, which is actually taking the material in your hand. You actually have presented earlier also in your studies, all these various things that you've done, all these things, which is, I think, a very healthy and a very proper process. What is important, though, is to not necessarily go forward with it just because you've done it. You should now critique your own, junctions of this. This material is flexible. If you notice, it is flexible, and I think Manjunath has already pointed out in terms of the rise of the, and the, bending. So if I was to jump on this, which people are going to do, it's going to do this, and 2 floors of that. So it may be a little weak in terms of, so you've chosen a material, you've gone all the way, because for whatever reasons, because probably they're one of your sponsors. So, sometimes these become difficult decisions for all of us. Yet, how do we use that material then? So use it in a way where you don't test its weakness. You take its strength forward. Yeah. So I would like to leave it at that, because I think we're running short of time. There's lots we can talk about, but it's a good, well-set process, and I think it's important to keep it in mind, to be critical about it also parallelly. Yeah. Thanks a lot.
Thank you for those insightful comments, jury members. Team Angra, thank you. So we'll be moving on to the 4th presentation. The 4th presentation for today is from Team Nova. They have worked on construction worker housing for building a water pumping station near Ukai Reservoir in Ukai village, Tapi district of Gujarat. And their project partner is Larsen & Toubro Construction. Could you please join me on stage, Team Nova? Kindly welcome them on stage. Thank you. Okay, so Team Nova, just provide you with the instructions. So you have 20 minutes to present your presentations to the jury members. At 15 minutes, we'll give you a ring, as well as I'll raise my hand to let you know you have 5 minutes remaining. You will not get a 21st minute, 20th minute, wherever you are, however is the condition of your presentation, we will stop you. All right. So once that is done, we'll have a 10-minute Q&A session. All right. So keep your comments and direct and short. Okay, I'll let you know. All the best. I'll let you know when to begin.
If there were no workers, marvelous architecture would have only lived in fantasies. As witness to this court ourselves, Team Nova, comprising of 9 architecture students and 2 engineering students from Jamia Millia Islamia, have come together with a vision of creating Asia for our construction workers, a dignified built environment which provides security, comfort, and peace to the workers. Under the context of net zero, the design addresses both social as well as ecological challenges.
More than 41 million people are engaged in construction industry in India. Many of these workers belong to the migrant worker community. These workers live near site in temporary shelters between months to years in poorly built shelters that are made from discarded building materials. These shelters lack basic amenities of clean water, consistent supply of electricity, and proper sanitation in an overcrowded environment. Going through our case studies, we also observed poor structural ability, insufficient natural light and ventilation, insufficient natural light and ventilation, along with claustrophobic spaces, with inadequate storage and circulation areas. To start this competition, we partnered with L&T WIT, that is a major name in construction and waterworks. The area of South Gujarat faces a scarcity in water. To counter this challenge, the Gujarat government, along with L&T, launched Tapi pipeline project that linked Ukai Reservoir to the command areas of Narmada and Surat district. Our site for this project lies in the Tapi district of South Gujarat, which is located in a very remote area, surrounded by forest and farmland. The site is taken on lease from local farmers, and the site lies in a hot and dry climatic zone. The occupants on this site are only bachelors, both men and women. The workers here occupy the site between 8 p.m. to 8 a.m. and the ratio of male to female workers is 7:1. Next slide.
So in our approach to address these challenges, we have designed a modular, lightweight structure which can be installed easily and dismantled easily. The units rest on a prefabricated concrete pier block. So a typical residential unit measures 4 meters by 5 meters, accommodating 4 workers and thus providing 5 meter square area to each worker. Next. Apart from the housing units, the site comprises of the kitchen and dining areas, washing areas, separate toilets for male and female, STP, water storage tanks, recreational areas in the form of parks and courtyard, as well as a crèche.
Now coming to the engineering operation, the the collapsible framework and the prefabricated concrete foundation and panel based on waste material and the inner fitting were selected for the reusability, low maintenance and life cycle. And the prefabricated concrete blocks foundations provide a stable foundation by distributing the load of the building evenly onto the ground. And the corrugated roof sheets can provide both the strength and the aesthetic appeals. The wall panels were slide into the I section framework. The main structural framework of the housing unit is made up of ISHB steel beams and columns. The sections were selected due to their high strength and load bearing capacity. The roof sheets were supported by 4 additional columns, 4 additional beams of square tube. The arrangement ensures the proper distribution of the load and structural stability. The flooring is supported by 3 channel section beams. And the ISHB steel beams and columns were connected using cleat angle. The cleat angle is a steel bracket with the holes for the bolts. The arrangement ensures, the bolted arrangement ensures the bolted arrangement ensures the structural integrity and the easy assembly and disassembly of the modular structure. By using the StatPro and analyzing the parameters like bending moment, shear force, and deflection, we have been ensured that the whole structure is within the safe zone and can withstand the anticipated loads and forces.
Next, coming to the energy performance, the materials used for the walls, floors and roof have a U value of 0.6 watt per meter square per Kelvin, which helps us to attain an EPI of 13.10 kilowatt hour per square meter, which is just the half of the benchmark that was set earlier using the standards. Providing the solar panels on the 45% of the rooftop area, we are able to generate a total energy of 1,45,500 kilowatt hour every year. Out of this, we are able to save 88%, which as a result makes our structure net positive. Next, coming to the water performance. As per the standards, the water consumption have been reduced to almost 60% from the base value by using water efficient fixtures such as water saving aerators. Out of the total water consumption, we have 9.4 kiloliter of grey water and 3.8 kiloliter of black water, which is generated every day. The grey water is filtered using a root zone treatment, which is low cost because it involves natural processes only. The filtered grey water can be reused for flushing, irrigation, and PV maintenance. Then coming to the rainfall harvesting, we have a total effective catchment area of 4,230 square meters on the site, through which we can harvest almost 4,947 kiloliter of water every year. Now summing this up, we have a total water consumption of 4,821 kiloliter. However, our total water production, that is recycled grey water plus harvested rainwater, is almost around 7,514 kiloliter, which is resulting in a net positive water storage, which is almost around 2,693 kiloliters.
According to Vulnerability Atlas of India, the site lies in seismic zone 3, making it prone to earthquakes of magnitude 5 to 5.9, with risk of fire as well as strong winds. To address these challenges, we've used strong mild steel frames and with cleating angles that provide strength to the structure, with use of Recron panels that are strong as well as have a temperature resistance of 105 degrees Celsius. With in addition to that, we've devised strategies for any adverse situation. Open areas for evacuation and medical facilities with alarm systems make sure to secure the site with provisions of backup energy and communication, medical aid, and essential items. Make sure that the site is ready for any worst case scenario. Talking about the embodied carbon, the baseline emission per functional unit has been calculated using the standard materials for worker housing through NBC, which comes as 439.3 kg CO2 emission, and by using our Recron panels and our design strategies, our emission, the functional unit, the baseline emission per functional unit, taking in account of standard building materials, comes as 461.4 kg CO2 emission. But by using Recron panels and our design strategies, the proposed emission per functional unit for our housing unit comes as 439.3 kg CO2 emission. So the total emission comes as 4,549.5 kg CO2 emission, and thus it makes that our one single unit housing produces a carbon emission of 22.009 kg CO2 emission per meter square. And to address these challenges, we've used Recron panels that are made from recycled plastic waste. It has a low carbon emission of 0.56 kg CO2 emission per meter square, and the materials that are sourced are within the 150 kilometer radius, reducing the carbon emission from transportation. And on-site construction worker housing achieved a minimal carbon emissions of only 22.5 kg CO2 per meter square. Panels are reusable and easily disassembled and reassembled, resulting in minimal material usage, and the need for excessive materials is reduced as they can be taken apart and reassembled. Talking about affordability, to make it affordable, we've used such electrical and water fixtures that save our consumption of electricity and water, and also we've used and the total project cost, the cost of a single room housing unit comes as 1,06,748 rupees, with the total project cost comes at 81,33,343 rupees.
Coming to the context of health and well-being, we have used the PMV method as well as the adaptive method to analyze the thermal comfort. So these are the different charts that we use to do the analysis. Next. Apart from that, for wellness, we have incorporated various strategies like clustered formation with shared interactive spaces, using specific vegetation for their olfactory and air purifying properties, using lights that do not interfere with the circadian rhythm of the user, and as well as apart from that, our panels are soundproof up to 33 to 39 SDC. So to ensure proper cross ventilation, we have placed windows in directions opposite to the flow of the air, flow of the natural wind, and the windows are on the opposite walls as well. Additionally, we have provided vertical folding windows which convert into overhangs upon opening, and we have also proposed the use of lowers and bamboo curtains over the windows to ensure proper shading and the quality of air within the space. So average comfort hours actually required for our site was 4,380 because our workers work for 12 hours, but still we have increased it to 5,475. Yet we are able to achieve 65% of comfort hours. Next.
The transportation for the taking account to the quick assembly, we've calculated how transportation and transportation will happen for this housing unit. So the walls, flooring, and roofing, as well as the structure and fenestration, all these come within 100 kilometer distance, below 100 kilometer distance, making sure that the setting up of these structures does not take much time. Since the strain of this Recron panel is established and is available can be available in adverse geographical places.
Now, combining our design with innovation, we have come up a consultant mobile application through which our clients can reach out to us to get their net zero housing designed by our team of experts. Through this app, the clients can go through our previous net zero projects as well as by subscribing us. They can even consult about the materials, the net zero construction and so on, and thus promoting our industry partners as well.
While designing this housing unit, we recognize the key issues, and the main key issues that are addressed here was safety and well-being of the workers. We'll tell the workers how this worker housing is better for them in cases of safety and well-being, proper comfortable ventilation, natural light, and interactive spaces promote better mental and physical well-being. Segregation of spaces ensures safety, and better living standard. The use of Recon panels ensures sustainability, so that there is reduces the load of plastic waste on Earth, and affordability. In a pitch to contractors, we'll tell how this housing unit saves cost through the use of less energy and water consumption that saves money in turn. Our design is also modular and can be easily transported and can be quickly assembled and dismantled. In the end, the idea behind this project was to make home for those who build for everyone. Thank you.
Thank you very much for your presentation, Team Nova. We'll move on to the Q&A session with the jury now. Alok?
Right. So, I thought you started really well with the, that no housing or no buildings or architecture would be possible without construction workers. I think it was a very strong start in terms of, evoking emotion. And I also saw that you had pictures of you in those homes. Did you talk to the workers?
Yes.
And I would have liked to hear a little more about how that informed your design choices. Because on the one hand, I saw that you spoke, that you were in the homes, but on the other hand, I don't know if, the 4 to a unit kind of, 4 residents to a unit, I mean, in my mind, it's just too crowded. But, that's, yeah, so that was a thought. Any response to that? I mean,
So as we interviewed them, their complaint was that it was claustrophobic, and the reason being that there were like bunk beds, and they were placing like 10 bunk beds within one room, and those bunk beds accommodated vertically 3 beds. So according to them, that was claustrophobic. So we have reduced it to a lot lower extent, and there's plenty of circulation space within our unit as well. And apart from that, there was like issue of storage. So we have provided plenty of storage within the space, and the windows were not present in their, sufficient windows were not present in their blocks. Like even if they were there, the bunk beds were placed in front of them so that they were not accessible or openable. So we tried to address all of that.
did you go back to them with your designs?
We didn't go back to the workers yet, but to the project part.
Yeah, I think it would have, I mean, so for one, like, I don't know how many teams did go to the workers to gather requirements, because that's how architecture usually works, is you gather requirements from the client, then you take it to concept and schematic and so on. I was not clear about a few things. I'm just going to kind of rattle them off. If you have answers, you can answer. So you mentioned the U values for the passive measures, but there was no mention of like the specific material choices that got you to the 50% reduction from load reduction using passive measures. I did not see that.
The materials were taken from the Ricron panels only. The flooring is also Ricron. The walls are also Ricron, and the roofing is also provided by the
And what were your base materials, baseline materials?
Baseline materials were sandwich panels. The normal sandwich panels that are used for the worker housing, that we have used for baseline.
Okay.
To calculate the embodied carbon as well.
Because you don't mention, so embodied carbon was another note. You don't mention baseline materials at all in the tables. It just says wall and roof and that kind of thing. So I was trying to figure out like what materials you used for baseline materials.
So baseline, yeah.
And then the resilience, if we can look at it, I mean, I feel like how were some of these aspects incorporated in the design was completely was not evident to me at all.
So for example?
On-site power generators, reserves and batteries, where are they? I mean, or, in the design, on the layout, right? I mean, I feel like there's a lot of, mention of things that are to be done, but whether or not that is incorporated in the design was not evident to me. And then finally, and I'll stop at this, I thought that with the innovation challenge, and I think this is something that even with the last project, is that, the whole thing with innovation is like, what's the idea, what's the problem you're trying to solve, what is the solution, how are you kind of, going to scale it, and so I'm not sure, like, मतलब किसकी problem, कौन सी problem, कैसे solve करोगे, कितना market है, कैसे बेचोगे, right? So who has this problem of like, and is it an app only for like construction worker housing, or is it an app for
So this is an
general
app
design?
for just the for just the construction worker housing. The module that we have that we have designed, we will place that modules with different layouts to different sites. But for this, the client need to contact us through our subscription and all.
Who's
so
the
that
client?
The client is the
project
contractor.
partner in our case, or otherwise the contractors.
Yeah,
So we are
contractors.
basically providing a platform for the interaction.
Yeah. This will create a client circle as well, and a source of income as well.
So this goes to the value proposition question. Why would they contact you?
So because we have various reasons. First is that it's net zero, and then we are creating it dismantleable and lightweight and easily transportable. Apart from that, the way we will design would be we would do the zoning as per the climate, as per the site, which is otherwise not possible if they try to do it themselves.
We will do it in a very shorter period of time through our team of experts and AI that are working behind. So that's our main thing, for a short period of time. It will not take months and all
If
to
you're
design
aware,
it.
previously we were actually working on the AI thing using the grasshopper to develop the scalability thing. So we are still working on that, and
But now we have turned that into a for now it's a consultation app for now. But then we will improve it once we get funding, and also then we can work on it and make it more scalable and all.
Okay.
Hi. Have you felt this material, the Recron panel? Have you held it in your hands?
Yes, sir.
And you know how thin it is?
So
Have
it
you?
comes in various thicknesses, like.
Yeah. What is the
So
thickness
for
you're
us,
proposing
we
to
have,
use?
For our walls, we have used 25 mm. Otherwise,
Corrugated or actual thickness?
Actual thickness.
Okay. And the roof?
Roof is for a 5 mm, but it's corrugated.
5 corrugated. Yeah. So you should, you know what you should do? The simple way. These are experiments and important. You should actually take a sheet, walk in the sun, you have on top of it, on your head, because sometimes these are important things to know, that how much radiation is it really going to. Why would I change from a corrugated metal sheet to a Rycron panel? Is it because that Rycron panel is my sponsor, or is there something of real value? I'm just going to be a little critical here about the Rycron thing, because I've been seeing it across quite a lot of cases, and I think it's important to understand there is a company here that wants to. It is doing a good job in terms of putting up a lot of waste into a more permanent material, let us say. But will it fulfill all the requirements of, let us say, we are replacing GI sheets? Now, just critically look at both and see why GI is used so much since the last 50 years, and you're going to ask to replace GI by this. We would like to. I would also like to. But then what you want to tell Ricron is, listen, these are the gaps that you need to fill if you want to beat this guy. What are those inputs you're going to give this company? Are you simply using it because they're giving it to you? You understand what I'm saying? Yes. So I think this is something that we all forget. They're giving this material to you, they're sponsoring you, means, yes, they're interested in putting it forward. They're looking for solutions from architects as to how better to use it. So, for example, if you use Rycron, if you use a GI sheet, your members, your horizontal or supporting members would be very less, because it also has an internal strength. Whereas Rycron does not have an internal strength. You would need far more members of steel to support it. No, you would. So where does the cost go? So you understand? So there are these kind of things. So what I feel, it is important to begin to understand this from that point, all of these experiments. It's important to experiment, definitely. It's not to say throw it out. Please tell them what are the gaps so that they come back better, because we want to use this material. Then, your C-shape. I think it's a great idea to have a C-shape thing, but then you prove that the air is going through one direction, but then if you look at your site plan, they're all turned around, all of them, to make nice courtyards and community spaces, which is good. But then they are turned around, so your airflow things will go a little haywire. So you got to be a little careful. Either don't state it that way, because it may not matter sometimes to actually show those arrows. What it matters is you have cross ventilation. All that matters is cross ventilation.
Yes, sir. So for this, what we were actually trying to do was like within our panels, we are trying to create certain panels that would have the puncture for the window or the door. So in case the orientation of the block is changing, so that particular 1 meter by 3 meter panel would go in with that puncture of the window would go in the place where as per the wind flow. Yeah.
And the other thing, in terms of simple architectural design, one of the simplest aspects of shading your walls, don't let your walls face the sun, which means overhang your roof, and it doesn't require much. It saves you from sun, it saves you from water. Most of the designs we are seeing is that their roof stops right at the edge. Like, these containers that we get, the regular containers. And whereas these are simple architectural details one must also, because when you open your door, the rain is going to come in.
Yes, sir. We have the overhangs.
Yeah, but it's not so much. So anyway, just think about it. Yeah. So I'll just pass it on. There are a lot of places. We are also running against time.
I think nothing much, but can you just take the structure? Why are these, these precast foundation blocks? Why? Can you just go to the foundation block?
Okay, yeah. So the reason we chose this was like it was a farmland, so we did not want to like mess up with the soil.
No, that's fine. This foundation block is nice, but why is that groove on the top? Is basically, yeah.
So the groove will accommodate the eye sections.
Okay. So it basically takes the flange of the eye. You said ISHP, You said some it is, you said some section, no? It's like the flange and the depth, the web and the flange is same, is it? Yeah. Why that particular section you are using here?
So because it will provide sufficient strength.
Okay.
And it can also resist the bending moment.
Okay, but what is the width which where the member passes through, it's there the size is much less. Yeah.
It's actually 100 mm.
Yeah. So how does it cross over? In the sense, you have a column which is I section, which is square, and then you also have a beam which is I section.
Yeah.
So how does it connect at this junction is something which has to be looked at. Okay.
One will be fitted in it, and other will be bolted with.
Okay. Do you have a section for that? Do you have something like that? Is there a section in your drawing?
So what would actually happen is that the beams would be landing on the...
What is that red color which is shown in the drawing? Yeah. It's a base plate, is it?
Yeah, yes.
It's slightly lesser than the column itself. So anyway, I think to me is the choice of element, the choice of I section, what you are choosing is fine, but only thing is how do you, in a span of 4 meters by 5 meters, which is almost square, the sections will be more or less uniform, It's not, there is no shorter span and longer span. 4 by, your plan is 4 by 5, no? Almost, yeah, so it's almost square. So we need to look at the connection details, which is very important. How does this column touches the pedestal? Then how does the beam touches the column? These profiles are very important to make a subframe for your cladding, surfaces. The roof is very important as a surface because we can't have any joint. How does the triangle portion of your roof be sealed if you have the frame which is more rectangular? Okay, so these are, when you are looking at kit of parts are things which can be built, somewhere you need to identify the way it is built. Okay, very important. And junction details are very critical in this, It's not, these are typical junction details. It can be for any building for that matter. It doesn't give you any indication for your building, Okay. So I think that's, what is the what is the density of this material, Recon? What is the density, do you know that? What is the density of that material? Yeah. Is it what, like 600 kg per cubic meter, or it's about 800 kg per cubic meter? And this has the ability to bend into a profile like what you do in corrugated. If that is the case, why can't the wall panel itself can be bent into a profile like a C, So there's a possibility of using these elements, these elements can, the material itself can bend into a shape, without, you don't need to add any element to support it, So it's fine, it's quite interesting. It's okay, I'm just curious to know. Thank you.
1.06 gram per centimeter.
Oh, what's kg per cubic meter?
1.06 gram per centimeter.
It's grams per, okay.
Yeah, grams per centimeter.
Okay.
Thank you, sir.
Question, I mean, for all the teams that are using Recron panels, are you having conversations with the industry partner? Or, I mean, you are having conversations, okay. Because so that's good.
All right, thank you, jury members. Thank you very much, Team Noah. So we'll be taking a longer than normal break now for lunch. So we'll start the presentation for Team 5 at 2:30. We request everyone to be here by 2:15. All right? Satwa is next, right? There they are. It looks like they already had lunch and came here, no? Look at the energy to present. All right. Online folks will be back at 2:30. Have your lunch and come too. See you soon. Good afternoon, everyone, and welcome back to SDI Finals. We are the on-site construction worker housing division, and we have our fifth team presenting now. That's Team Satwa. So everybody had lunch, right? Yeah. Good? Tasty? Yeah. Our jurors? Yeah? Nice. I see Alok nodding. I see Alok nodding like this, you know. Acha tha. Okay. Yeah, so you need to entertain them. Do not, I mean, I know everybody's stomach is full and sleepy and all those things, so, yeah. All right, so we have Team Satwa 2.0. Is it 2.0, 2.0? How do you say it? 2.0, all right. Please come on stage. Yeah. So they have worked on the construction worker housing for the Indira Gandhi National Center for Arts in Central Vista, Delhi. And the project partner is Larsen and Toubro Construction. All right, let me just, I think I did open your presentation. This is yours, right? Yes, sir. All right. Okay, so I have to do my due diligence. Okay, so I have to give you some instructions. So you have 20 minutes to present to the jury. After 15 minutes, we'll ring the sustainable bell. Okay. And I'll also raise my hand visually. No 21st minute. Yes. If you're not done, I will come up on stage to stop you. All right, obviously. Okay, he knows it. Okay. Jury members will have a Q&A session after that for 10 minutes. All right, all the best. I'll let you know when to start. Oh, okay, so I didn't see that.
Good afternoon, everyone. We are extremely honored to present our project Nile in the on-site construction worker housing division. We, Team Satwa, are a team of passionate and environment-conscious members from the University School of Architecture and Planning, IPU, from New Delhi and IIT Roorkee. Our faculty advisors have been an invaluable source of wisdom and inspiration, consistently fostering a sense and environment of intellectual growth and development. India has a vast pool of construction workers, estimated to be around 40 million people, making it one of the largest construction workforces in the world. However, their needs and their housing needs are little understood, forcing them to live in dismal condition. With a desire to address this issue, our team took up on this division. Our project partner, L&T Construction, is the division of Larsen and Toubro, founded in 1934. We work together with our industry partners, one of them being Premier Energies. Another influential presence in our designs was of architect Gaurav Shaurya, who is one of the founding members of the Griha rating system. In the design management process, we divided ourselves as per the contest, keeping in mind achieving a mindful balance. We conducted case studies and analyzed all the problems it solved, along with trying to grasp the real-life situation and station of the construction workers through interviews. The SLMs, webinars, and the discussions we conducted with our project partner, faculty partners, and industry partners helped evolve our design to completion. Our site project lies in the Central Vista, New Delhi. The current site is the Indira Gandhi National Center for the Arts. Our detailed target group study revealed 2,500 male construction workers that are housed in modified shipping containers on site. The site operates in 3 shifts, each of 8 hours. It is a double-story housing structure with 104 containers, and each container houses 24 workers. The current style and construction and the provision of amenities on the present site and scenario is beyond the usual construction workers' housing. However, there are still some problems that we uncovered. One of them being wastage of water, lack of thermal comfort, and etc. Therefore, we aim to reduce the energy, waste, cost, and water on site without introducing anything permanent.
To provide a comprehensive solution to all the mentioned problems, we have executed our design based on 10 contests with an additional contest. The proposed built-up is of 9,900 square meter in a north-south orientation, accommodating existing tree foliage. The washroom and bathing areas have been provided with a slight offset from the main living zone to be mindful of the order generation. The provision of recreational area in the form of dining area have been provided in front of existing kitchen. The offices and medical unit lie in a separate zone near the construction site in terms of management and supervision. Structures like vegetable store, general store, and a minor cyber cafe have been provided. The services are located at the periphery of main residential block, providing biodigester in the proximity of toilet, RO plant near the kitchen, and shops near the offices. In a typical cluster, the building includes multiple interactive spaces like angan at floor level, courtyard at building level, to recreational area at society level, providing better social interaction and community engagement. A 5 meter by 5 meter module houses 12 people employing bunk bed. It includes storage spaces for each worker, double window on opposite wall to accelerate ventilation and attain thermal comfort. These units are then stacked to form a G+2 structure. Our design aimed to use modular construction approach. The ease of assembly and disassembly is ensured by the use of grillage foundation and mild steel box section. This also result to help the least disturbance to the site topography. Kit of part is an object-oriented approach. We innovated to attain modularity. Our design, next slide. The wall panels have ferro cement exterior finish that is insulated with corkboard and have particle board interior finish. The flooring structure include fiber cement core with corkboard insulation to attain thermal comfort and linoleum flooring. The underside of the flooring have particle board finish. Our module can be assembled in 5 simple steps. The first step is to add flooring member. Second step to add structural member. Third step to add wall panel that have already made cutouts for fenestration. Fourth step to install fixtures and doors and window. And final step to add furniture and roofing member to finalize the module.
The electrical plan has been thought of as an integrated approach. 3 10-watt LED lights have been placed in the rooms to illuminate the space, and they have been placed according to window locations. 12 wall-mounted fans and sockets have been placed according to room requirements and right sizing. Bulkhead LED lights have been used in the corridors and near the washrooms. The plumbing plan shows the location of storage tanks and the piping layout on our site. The freshwater tanks have been placed near the kitchen. The grey water tanks are placed near the bathing units. And the black water tanks have been placed near the biodigester plant and the toilets. The structural stability analysis on StatPro shows that our structure is stable under maximum nodal displacement and absolute maximum stresses. This shows that our structure is in the safe zone for living. Materials can have a negative embodied carbon if the emissions during manufacturing is less than the total carbon embedded in them during their raw phase. Previously, modified shipping containers were used with X-space insulation as the structure for the design, and particle boards with linoleum were used for internal finishing. UPVC windows with floored glass were used as fenestration. Keeping our goal in mind to provide to create a durable, transportable, temporary and net zero embodied carbon solution, we have used corkboard insulation to provide a thermally comfortable and a lower global warming potential housing to the workers. The kitchens present on the site have been reused, which means the total global warming potential for the kitchen structure, the wall and the trusses is zero for this intervention. The proposed design registered a decrease in wall, roof and floor assemblies, but an increase is seen in the fenestrations, which is due to the increase of WWR in our design proposal. The proposed structure shows a decrease of 40% as compared to the base case, which is due to the use of mild steel hollow box sections, which are made of 59% recycled steel, which has 70% less embodied carbon when compared to virgin mild steel box sections. As a result, the total embodied carbon of our proposed design marks a reduction of 102% from the base case.
To attain a net zero solution, 4 steps have been taken up: reduction in consumption, wastewater reuse, rainwater harvesting, and groundwater recharge. By using efficient measures, the base case freshwater demand of 161 LPSG was reduced to 59 LPSG and was further reduced to 8.3 LPSG by using efficient grey and black water treatment systems. For the wastewater treatment, we are innovating the Ecotech process developed by the EcoHealth Products Private Limited in Chennai. It uses herbicides that are eco-friendly, cost-effective, scalable, and uses herbs like neem and moringas available in the market. For the grey water collected from the bathing, cleaning utensils, cleaning clothes, and others is collected and treated by a combination of EcoClean 20 and EcoClean 50, which gives an efficiency of 95%. The water goes through a sand carbon filter and is collected, where EcoClean 20 is added to remove the suspended solids. EcoClean 50 is then added to remove the bacterial suspends like E. coli and is then collected and sent for daily uses. For the black water collected from drinking, cooking, and flushing is collected and treated by EcoClean 2300, which gives an efficiency of 70%. The water goes through a sand carbon filter and then EcoClean 2300 is added, which removes the suspended solids and is then used for flushing demands. Our site has a total runoff potential of 10,584 meters square. The water from the rooftop is collected and treated for the potable uses for the months of July, August, September, October, and January, and the rest to make a total of 3,200 kiloliters of rainwater harvested annually. And the rest of the months are treated by Delhi Jal Board. As the last strategy, the groundwater was recharged. The untreated water from rain, grey, and black water is collected and treated to make a total of around 9,480 kiloliters of water sent back to the ground by groundwater recharge. Hence, we make a 10% net positive solution, and a total of 5,450 kiloliters of water is sent back to the source by groundwater recharge. Waste is another aspect we as Team Satwa believed is necessary to achieve the net zero cycle. Hence, we introduced the waste disposal and management as our 11th contest. In the categories of waste generated, dry and wet waste are treated on site, and the hazardous waste are dealt at occupant level. The waste is collected in separate tanks, separate dustbins envisaged near the housing and kitchen on our site. 70% of the waste, human waste generated, and the kitchen waste is biodegradable and can be converted to bioenergy. The Flexi Biodigester is an inexpensive, portable, and compact solution. The site produces a total of 837.5 kilograms of human waste daily. This waste is fed to the PVC tank and an anaerobic process happens. According to the Buswell calculation, 33 meter cube of biogas is generated on site daily. If we use a combination of biogas and LPG, we see a reduction of 15% in the usage of LPG.
Now, talking about the energy performance of our proposal, we are achieving an EPI of 18 kilowatt hour per meter square year. The process to achieve the total energy efficiency in our case was divided into 3 parts. First being the energy demand reduction. Now, this entailed the employment of passive strategies and an energy efficient envelope design. The second being the reduction in energy consumption was catered to by energy efficient appliances. Finally, we are generating on-site energy. The passive strategies that we used included keeping the massing such that the mutual shading is achieved and maximizing the convective ventilation of our units. We have provided sail shades for open spaces, which reduces the heat gain from our walls. We've used recessed balconies and to further reduce our heat intake, and solar panels on roof have been employed. In the envelope design, we are attaining a U value of 0.31 watt per meter Kelvin. Since the rooftop receives the maximum sunlight, solar panels have been employed there. We are using the half-cut monofacial solar PV cell by Premier Energies. Now, keeping in mind the affordability and the efficiency of our product, we are attaining around 2,77,400 kilowatt per year using 1,000 panels. Now, this actually gives us a surplus of 55.11%, and hence we are providing a net positive solution. Now, Delhi has a composite climate. So we attained a WWR of 24% with the UPVC double glazed windows that have a 16 mm thick argon cavity, and it is sandwiched between 4 mm thick low E glass. Materials with minimum or low VOC have been utilized, such as ferrocements and particle boards, and low U values have been used for our assemblies to ensure thermal comfort. Now, keeping in compliance, our operative temperatures in the living zone turn out to be 30 degrees Celsius, and in the office zone turn out to be 27 degrees Celsius, and we are attaining 2,700 hours of daylight annually in our sleeping units. Now, for the mental well-being of our workers, we have provided through effective cluster planning. We have provided angans and courtyards, and to cater to the chances of epidemic breakouts, we have provided better sanitation measures and waste segregation on our site.
So our site can potentially face hazards like earthquakes, strong winds, thunderstorms, heat waves, and pandemics. So evacuation drills according to the evacuation plans and training to handle the fire equipments must be held regularly. Our design provides an autonomy of 48 hours in terms of water and energy stored in the form of solar energy in 18 batteries. Efficient handling of structure led to the optimization of construction cost and transportational cost. The proposed design capex is 11,450 per square meter, and the proposed design OPEX is 497 per square meter per year. The use of solar panels reduces the operational energy by 65%, which overweighs the cost of investment. The project NILE aims to elevate the housing conditions of the on-site construction workers and to provide an scalable, affordable, and modular solution to the project partner. The project addresses the socio-cultural needs of the on-site construction workers and provides an improved comfort, environment, security, sanitation, and well-being for them. In the end, overall, we helped in the upliftment and improved productivity of the construction workers. Thank you.
All right, Satwa 2.0. They finished 3.5 minutes ahead of time. And I'm pretty sure I can speak for the jury that it was entertaining. It was entertaining. It was entertaining. Okay. Calm down. Okay. So we'll move on to a question and answer session with the jury now. All right. Are we ready?
Hi. You're one of the few who've gone 3 floors, ground plus 2. Yes. 3 floors. You want to tell us why?
So because our site is in Central Vista and they have restricted area, like they cannot go beyond, but they have a lot of construction worker, 2,400 construction worker. They like, so they cannot increase the ground coverage, so we have to go up.
I understand. Just because you'll be challenged in terms of foundation.
Yes, sir.
So would you want to tell us something more about what you, because I don't know whether you explained much about your structure foundation.
Okay, sir, we use grillage foundation that goes under 1 meter deep inside. It's kind of shallow foundation.
Okay.
So it is temporary foundation and we use that.
Yeah, I think I'll leave that for Manjunath to, I think he has some, I think, questions on that. I remember when we were discussing this. Yeah. I think largely your site plan was very nice. It was well thought out, practical. I especially appreciate that you try, because I can imagine that Central Vista area has got a lot of trees and you had to kind of weave this project amongst the trees.
Yes,
and
sir.
so it's well done and organized in a certain way. I really think this is the only project I've seen where there's a Dobby cut, you know, which
Sir,
is, I think, an extremely important thing when you realize that that is so easy to do and you can just simply dry your clothes, which is a wet thing, which is away from the residential area. And that's in fact so practical. So in the same way, Wayne, I'd like to ask, did you think bunk bed versus any other, again, is it density?
Yes, sir. It's because of the density, but we knew that because of the project partner, they don't have lot of space. So what we did, that is kind of a sleeping pod area, but we knew that these people also need some space for recreational activity and for other activities. So we provided common angans, so that because the workers come from their villages, they are migrant workers, so they live here alone. So like it help to achieve community engagement and interaction and all.
Yeah. So that was, since you've made bunk beds, did you think architecturally it would make any, like you seem to have put the bunk beds in a room. Would your architecture have been any different? Would there be a potential, like if I'm in the lower bunk bed, do I get a sense of a window, or I have, because your windows are on the upper floor, upper level.
So we have provided the section in report. So what we did is, there is 2 windows on. So there is 2 windows.
One of the window is here and one is there. So we are providing 2 windows. So the one on the upper bunk bed would also get a window, and the one on the down one would also get a window. That's why we are achieving a WWR.
The center guys don't get a window. The outer.
Yes, sir. Yes, sir.
Yes, the central one.
Yeah.
Would
So
not get a
you have to compromise a little bit.
No, suppose your storages weren't where they are, and that's where the openings are. Everybody gets a potential part of a window in a different way. So anyway, so these are small things, but the idea is that when you put equipment in, the equipment has to decide how the spaces are going to be experienced. So that's a small thing, but I think it's important. The other thing is, well, that's a complex thing in a bunk bed situation. Shuffling beds is complex, so that one can understand. I think Manjunath will have something more to say on the bunk bed issue. I'll leave that also to him. The solar panels, the final roof, could the final roof have been sloping itself so that the solar panel doesn't need a structure of its own? So, you know, in a way that itself slopes and takes care of the rainwater, and default your rainwater is collected in a certain way and, you know, used in a certain way. I really appreciated the covered courtyards, which is very nice. It's a nice shading in the courtyard. It allows, because Delhi is very, very hot. Even in winters, in the day it's difficult. You can't stand in the sun beyond a point. Yeah. So it's nice to see that there is a shading in that space. It allows the building not to get so heated on certain sides. Yes. So why are there 3 kitchens?
Sir, actually, what L&T is doing right now on the side, they have divided the people in the group of 6, and so every 6 number of people have a group. So every group got a cabinet in the kitchen. Like there's this 3 kitchen setup is already set up on the site. So we didn't did anything to this structure. We just using that is existing provided on the site.
But why 3?
Okay. So
You asked? No, you didn't
no,
ask.
sir, we didn't ask. I didn't thought about
You could have
this.
used it as 9. One of the 10 could have become a 9 as a suggestion. Anyway, so the other thing, I'll now come to the unit itself. Your panel is well designed. You've used a fiber sheet, which is far more easy to manipulate. You've tried to make it, you give it a UV value, but do you know you've used one of the most expensive materials? Do you know the cork sheet cost?
Corkboard insulation, yes, sir.
You know the cost? I found it, I was shocked. I mean, when I was reviewing your thing, I also wanted to know. And I mean, it's super expensive.
Sir, actually, we did look into some other insulations, but some insulations which were cheaper or waste products, we could not actually find the proper embodied carbon values for them. So we wanted to create a project in which we can actually calculate the embodied carbon and other aspects.
So for that, that's when you need to experiment. You need to put material in, like even cotton wool or any other stuff, and then put sensors. And come on, with your institutional backgrounds and engineers around you, you can easily. So, but these are necessary. This is not going to happen, no. I mean, just to fill in a blank and say, listen, I managed. It's not a race to come to a number 0.
Yes.
It's not that. It's an idea that hopefully we can actually make this a reality.
Yes, sir.
So one would have expected a little more ingenuity in terms of that operational. Don't necessarily take products that are available off the shelf because all data is available. That's a trap. Because they want you to use their material, so they've given all the data. But you know how to test them. So test new stuff, and so that I think was something that I'll leave this here and I'll give this to
Actually,
Manjula.
for the cost issue, even with using the cardboard insulation, we are like achieving a good number in affordability, I would say. So I think that even with using the corkboard insulation, which is a good insulation in terms of thermal comfort, I think L&T can use it because the overall investment is like...
You try convincing them, and if you can get me a letter from them that they will use this in their panel, then I'll come back and give you a different kind of medal.
Yeah, I think if you can go back to the structures, one slide. Yeah, yeah. So I think considering Delhi as the site, so you have silty sand. Basically the SPC is very low. It's of the order of around 12 to 13 ton per square meters. So the choice of foundation, then the spread of this ground plus 2 structure uniformly on the ground, is also very important. Second thing is about seismic, it's, zone 4, right? So we need to look at that because you don't have any bracing in the structure, okay? And so why, and considering that having, you have these bunker beds which are more or less concentric, throughout. Why can't even the bunk bed also is a house by itself, it has 4 supports. Why can't we look at that as a structure?
Yes, sir. Actually, we did not think of it like that. We were amazed actually by your idea when you said that.
Actually, when we received the review, that's when it struck us that it could have been a really good move, and we failed to explore in that direction.
So because what is in most of the cases where warehouses, when they are stocking materials, the structure, the support structure of the elements where that itself becomes the structure for the whole building. So that is one way I was looking at. And second thing, how did you manage to do cantilevers? Because your cantilevers are not continuous. The members for the balcony, because that is not very clear. All the balconies, how does the structure? It is not a continuous member, no. It's a connection at the point of the node. So how do you support the balconies is very important. Because balconies are not, it's not continuous member. So if that has to be continuous, the other member has to be, simply supported. That is very important to look at, so that you get continuity, and that's how the node can be designed. And these nodes have projection away from the support structural system. If you are using 150 square section, is the node slightly beyond 150?
Yes, sir.
If it is beyond 150, then how does these panels interact at that location, at the nodal location? So how does the joints, there is a problem, no? So these are very, see, when you are, one advice is when you are doing kit-off parts, kit-off parts basically is an explode, it explodes each element the way it is built. So you can't make a mistake, because every point will allow you to understand how it is built. Okay, when you are looking at a seamless construction like columns, masonry, then plaster. Anyway, plaster and paint will cover everything, no? Correct?
Yes, sir.
Huh? So they may, instead of 1 inch, they will do 2 inches plaster, or they will finally make it beautiful by paying a paint, whatever it is. But in this structure, every element is to be identified to seal all the joints. And every element has to receive the other member, Yeah, so when you are detailing something, just identify whether it is okay. Otherwise, you are expressing and exposing all these problems in the, okay. Huh? Yeah, that's it.
So the wall panels are to be assembled on site, is it? The way you've presented them,
Yes, sir.
They will be assembled on site. Where, like to the question that Surya, where did you get the corkboard costs from? 60 rupees a square foot. That's really cheap. I don't know what Surya is talking about. I know, so that's what I've seen with some of these cost estimates, is that, I've asked some questions about some 23% efficiency solar panels for like a ridiculously low fee or those kinds of things. So, like, where's the cost?
You probably got a 6 mm thing. You're using 100 mm.
Yeah. Okay, sir. And can you just go to slide 20? Again, same question, different team. For a material that's manufactured, how is it possible to get negative emissions?
So a manufactured material can have negative embodied carbons, like for any material that is made of natural fibers. It stores carbon in itself when it is in its natural form, in its raw form. It stores carbon. And when we manufacture it, we actually release some of the carbon it has stored in it with time. Like when the material is manufactured, it is being processed by some machines and everything. So that consumes some fuel that adds to its carbon expenditure. And like, yes, but if the carbon released during manufacturization is less than the carbon that is stored in the material during its raw phase, then the material can have minus, like negative embodied carbon.
Good attempt at rationalization, but I don't buy it. And I don't think you should either. Because the whole kind of premise of manufacturing or construction or development means that there is going to be a detrimental impact on the footprint. Even if it is a natural material, by taking it out of the ecosystem, it is going to be carbon negative. So just fundamentally, I think that, just because you have read something somewhere, or you kind of, are wanting to convince yourself about the fact that this is true because it is your solution, healthy skepticism about all claims. How do you do groundwater recharge? You've claimed like a few thousands of kiloliters of ground. How are you doing it on site?
Sir, on site we are proposing recharge pits, and for that we'll be collecting and treating the water, and then we'll sending it to the recharge pits, and then it will. We are assuming that other than the surcharge of the rainwater that goes directly percolate through the ground, this water will go through the recharge pits, and the surcharge of the rain is not calculated in this value because we are not considering ki uska how much amount of that water will go, and that's the additional that will go. But for what we are treating and sending, that is the 9,480 kiloliters sent annually.
Okay. And then the energy performance and the embodied carbon, what are the baseline materials? It wasn't very clear, and I think maybe you've already kind of covered it, but.
So for the base case, the existing structure had shipping containers with XPS insulation in them.
Okay. So these are reused, right?
Yes, sir.
So there is also embodied carbon benefit to the reuse of shipping containers.
So for the embodied carbon of shipping containers, actually, like we had a doubt. How can we calculate the shipping containers embodied carbon?
Like we've made an attempt from our side, but we are also like not.
So you can derate it for like the fact that it's second use or something like that. Maybe you kind of.
How much reduction can we mark in that, and how can be done? Like we used actually the calculation values from an Australian study. We talked to our TRG about that, and he suggested that we can use that if we cannot find that.
So how much did you discount it by?
So we did not discount it because that value for the the value for the shipping containers, it was 3,700 something kg CO2 equivalent. We used it as it is.
Okay. Okay. 31. Can we look at slide 31 just quickly? I was not very clear about what are we showing here. I know the title says daylight analysis, but what's the color scale? It goes from 1.4 to 81.4, so I was not very sure what are we showing here.
So
and then you have temperatures on the side.
Sir, actually, this is a UDI analysis.
Okay.
So the scale shows the percentage of illuminance on the work plane.
Okay, got it. Okay, so this part has nothing to do with
Yes,
this
sir.
part.
Yes,
Okay,
sir.
all right. Yeah, because when I saw the temperatures alongside this, I was like, wait, what? Yeah. Okay. Do you have a sense of how much you're spending per construction worker?
Sir, we have a sense in terms of LCC, 50,900 something in 10 years. On considering capex and opex both.
Per construction worker?
Yes, sir.
Okay. So that's okay. So 10 years is 120 months. So
yes.
Yeah, that's pretty good. 5,000 a year. Okay. Okay, yeah. Yeah, I'm done.
I think it's mostly about affordability. I had some issues in terms of for example, one is affordability, the cost, because the same question, an extension of that. Is there a detailed breakup of every item element?
It is in the appendix.
So it is in the appendix of the report. We haven't.
You haven't worked on it again? Okay.
We don't have it in the presentation, just have it in the report.
Yeah. Okay. Then we don't know whether you have some of the comments we've done earlier was we don't know the cost of your biogas system, solar panel, firefighting equipment.
We have incorporated everything
in the new.
No, sir. Sir, the table already consisted all of these values. We changed the name. We changed the name for a few, like for the ecotech, we didn't use the word ecotech, but like we used waste treatment system. So Similarly, for the fire, we already added the fire equipments, we already added the values, and the table consists all of them already.
Well, I don't remember that when I saw it last. It was we don't.
Sir, it's in the appendix. The table is in the appendix.
We'll find it. The other thing is maybe just a small design issue. The south balcony versus the north balcony. You may want to treat them differently in terms of shading, because they're facing each other. One is south, one is north.
Sir,
Just a design thing. You could take
sir,
it further.
actually, the site orientation is like the upper side is the north,
Right.
and on the southern side we have lot of very heavy foliage trees, and the calculation for our sunshade, that is kind of balcony. There is also a balcony. We did the calculations for the southern side, not for the northern. So this is the extreme case.
Okay. Fine. I think that's. You have one.
Just a question. How did you support the staircases? Everything is in the air right now.
Sir, staircase, it is a steel staircase, so
it is anti-gravity anyway.
No, sir. Obviously not. So it's have his own.
No, but
it have its own support system. Like,
how do you know? Just take the photo of just show the 3D.
It's a modeling issue, sir. It's a modeling issue.
Okay. Thanks.
All right. So, how was the Q&A? Are you sweating yet? No. Okay. All right. Thank you, jury members. That was a very intensive session so far for the day. Okay. So everybody has had lunch, and they also have the energy to ask so many questions. All right. Thank you so much. Thank you, Team Satwa 2.0.
Thank you so much.
So, going on. Oh, we have a lot of crowd. People have come back here. Welcome back, everyone. So the final presentation on the on-site construction work and division for today. We have Team Tridara. Tridara is here? Okay, they're coming up. They have worked on a construction worker housing for a 17-floor residential building in Mundunuri Residency, Kompalli, Telangana. And the project partner is AGR Infra Developers. I request you to please join me on stage. This is your presentation, right? Yeah. All right. So, Team Tridara, you have 20 minutes to present your presentation to the jury. At 15 minutes, we'll ring a warning bell, and I'll raise my hand visually also. After that, you will get 5 minutes to complete your presentation. You will not get a 21st minute. I will stop you wherever you are after the 20th minute. Okay? So, we'll just go down. All the best. I'll let you know when to start. You have a mic there, so yes. All right, Team Tridara, your time starts now.
Good afternoon, jury members. We are Team Tridara. Good afternoon, jury members. We are Team Tridara, representing Manipal School of Architecture and Planning. Manipal School of Architecture and Planning is a constituent of Manipal Academy of Higher Education. The core values of the architecture department are enabling sustainable endeavors for societal well-being and encouraging inclusive and sustainable design. This has encouraged many students like us to challenge ourselves by taking part in engaging competitions like this platform. I'm architect Naveen Kumar, team lead Tridara, and this is Aisha Suman, architect Aisha Suman. We both are postgraduate students, masters in sustainable design. I would like to introduce you to Mohammad Samar Iqbal and Madhusmita, third year architecture students. The rest of my team is a diverse group of architects and engineers who are green-minded and want to make an impact in the sustainable domain. On-site construction worker housing is the least considered building sector all over the world. Lack of ventilation, no proper indoor thermal comfort, lack of hygiene, overcrowding living spaces are some of the present living conditions of the worker housing. Our team took up the challenge to address this and improve the standard of living on the on-site workers.
So some of the goals and strategies that have been adopted are net zero energy, safety and flexibility, less carbon emission, easy to handle and less material wastage, net zero water, safety in the quality of indoor thermal comfort, design to travel, and adoption of various factors and solution to benefit the project partner. So let me give you a brief introduction to our project partner as well as our site. So our project partner is AGR Infra Developers from Kompally, Hyderabad. So they are mainly developers in multi-housing sector. The objective of our project is to achieve thermal comfort to the construction workers as well as to understand their needs and requirements. So the modules that we have adopted are completely modular and can be sustained in any climate types, any climate zones of India. The site that is located is in a suburban area with developing residential layout. Unlike other projects where the labor camps are detached from the live site, here a narrow piece of land has been allotted for the construction worker housing. So some of the challenges and the requirements that was addressed during the pre-design phase has been listed as below. So the site is located in Hyderabad. So Hyderabad experiences a composite climate alternating between hot and dry period to shorter period of rainfall and humidity. So the comfortable months comes between July to February and uncomfortable months is from March to June. So because of this, only 15% of the hour in a year comes within the comfort band. As shown here, the solar radiation is received maximum in the southeast to southwest direction, and because of this, we have arranged the blocks in such a way that it mutually shades each other as well as the common spaces. We have also placed panels in such a way that there is this reduces the heat gain through envelope. We have also given the window to wall ratio of 20% looking into this. Also, we have gone for translucent louvers which allow diffuse lighting into the module. As you can see here, the major prevailing winds is during the summer months is from southeast, and because of this, we have arranged the housing blocks in such a way that it deflects the hot winds from the openings to create a negative pressure area while helping in convective cooling.
Coming to the design process, after conversing with the project partner and workers, we came up with a detailed area programming while addressing all shortcomings at the present site. The ground coverage is less than 40%, while optimizing the size of module and considering maximum workforce. The modules can be arranged together in larger sites to create a neighborhood feeling. In architectural design, first we analyzed the hexagon shape with different geometrical shapes. We analyzed it on different parameters like solar radiation, indoor air temperature, outside air temperature, surface area, operative temperature, discomfort hours, and the material used in different shapes. We concluded that hexagon is more efficient in case of geometry as well as in energy efficiency. We designed 4 types of wall panels, which are a panel with louvers and windows, panel with door, and a solid wall panel, which can be used in different sites according to the requirement at different geographical locations. The whole module is standing on a plinth raised around 500 mm, which gives a convection cooling as well as allows the water to flow easily in case of heavy rainfall. This is the electrical layout. All the electrical fixtures will be connected to the smart grid for easy control and easy monitoring. The process of assembly goes in 9 stages, where we start with the placing of plinth. Then we place the base perimeter beams, which are connected with the secondary beams. On the peripheral beams, we have U channels, which will hold the wall panels. Then the columns come, and above the columns we have top beams, including the peripheral beams and the secondary beams. Then the U channels are slided into the wall. The walls are slided into the U channels, and the floors are placed. And at last, the roof panel comes. We also did a structural analysis for the dead load, live load, and seismic load, where we found that our structure is stable. The process can be shown in the GIF. The modules can be made in a cluster in different sites according to the requirement of the site. The joinery details we used on for the columns and for the peripheral beams, we have circular section beams with screwed joints. The secondary beams, which are the square sections, have bolt joints. We also have telescopic plinths so that we can adjust the height of the module according to the site requirement.
So energy. So we arrived at the base case after going through several case studies, looking into the typical construction worker housing in different states. The commonly seen materials are GI roof, GI sheets for the roof as well as for walls, or with masonry wall with concrete flooring. And the base case was then simulated in Design Builder, and an EPI of 47.3 kilowatt-hour per meter square was obtained. So for the proposed case, strategies such as high-performing materials for the wall, roof, and for glazing has been utilized. And we have also gone for night flush cooling. We have also looked into efficient lighting fixtures to achieve occupant comfort as well as energy efficiency. And for the roof, we have gone for high SRI, which reflects maximum of the solar radiation. Also, each module has been provided with solar panels, and it has a battery backup of 72 hours in case of any scarcity of power. And the excess amount that is being generated, it's sent back to the grid. We have also gone for smart power boards, which measures the flow of electricity, as well as it also operates the schedule in the module to control the lighting. So these are the passive strategies that have been adopted, and the percentage reduction, making this a net positive building.
Water performance. Considering the standards from NBC and other reliable sources, the consumption of water is derived for the base case. In comparison to the base case, the proposed case cuts down the domestic water use by 54.4% using aerators, e-toilets, bucket bath, rainwater harvesting system, and treated grey water. The harvested rainwater is filtered and sent for various purposes such as laundry, e-toilets, bathing, washing of utensils, etc. Grey water treatment systems have been installed on site to reduce the water purchase from the municipal for non-potable purposes. The treated grey water is returned for further use. all sewage from toilets is collected and channeled into a biodigester system. And the byproduct is then used as manure or sold, hence generating an income for the laborers. Mist cooling uses treated grey water to cool down the air entering the modules, which work on the principle of evaporative cooling. Embodied carbon. Majority of the materials used are prefabricated building components, which are green pro-rated and eco-friendly, having very less embodied carbon. These materials require less machinery and on-site labors during assembling and disassembling. So in this slide, we see the difference in emissions for the roof, floor, and structures during, between the base case and the proposed case. Resilience. In this slide, we discussed about how our modules are designed to adapt and overcome an emergency situation. Talking about food and energy security, the vertical farming of leaves and vegetables, which require very short harvesting period, are harvested on the site. Energy generated from PV solar modules act as energy backup for 3 days. We have high performance wall panels and roofing, which ensure occupant comfort in different climatic conditions. Ensuring, the roof panels can withstand the wind speed up to 39 meters per second, and the wall panels are fire resistant up to 4 hours. To ensure the autonomy of the operation during an emergency situation, we have curated an evacuation plan where the workers are trained to operate during and after disaster hours.
Here, the thermal comfort study is done using IMAC, and for Hyderabad, most of the operative temperatures for many of the months comes within the comfort band. Strategies for improving natural ventilation, indoor thermal comfort, and outdoor stress have been carefully curated. Internal CFD simulation was analyzed to ensure no stale air zones inside the module, and we've also developed strategy to displace the hot air with the fresh outcoming air. Innovative strategies to improve natural ventilation using eco-coolers, farming of green leaves, and vegetables on the site helps to sustain food scarcity during emergency situations. Segregation of waste will not be possible without the cooperation of the on-site workers. Dry waste bins have been provided at regular intervals along the site, and weekly collection of this waste will go to the recycling plants. Wet waste from the kitchen will be composted, which will generate biogas and manure for agricultural needs or to generate income for the laborers. From the above discussion, we can say that the housing for construction workers has been disregarded from by the developers and the contractors. Even more so is an efficient design with basic amenities. Project Aru is designed using a data-driven and integrated approach to propose solutions to the problems which are affordable and can be implemented at a larger scale. Speaking in monetary terms, we can see the difference between the conventional case and the proposed case, and hence conclude that our proposed case is a win-win situation for the users and the contractors. Thank you.
All right, thank you. Team Tridara, you finished well ahead of time. Okay, shall we move on to the Q&A? All right. Jury members? Alok?
I would like to get the model to the table of the jurors.
Sure, yeah.
using a 5-ton truck capacity. So every truck with 15 tons can carry 5 of our modules, which reduces transportation costs. And also, when I come to the basic structural members of the module, we can see the peripheral beams circular and then the pinned and the screw joints in the ends. We also have U-channels which allow the wall panels to slide into place and then rotated back to its position, which will be braced with the main columns. And then the floors and the walls, and then the floor and the roof, they go into place. This is Project Arrow for you, sir.
The hinge. You said it can be folded and then put horizontal.
Yes, sir. We have a rubber seal at the hinge, so that just like a car door, as it pushes, so the rubber seal pushes into place.
No, I know the car door.
Yes,
Yeah. Car door is vertical, right?
Yes, sir.
But this is horizontal.
You're talking about this hinge.
No, no, this the center
The
fold.
folding,
Yeah,
the
yeah,
folding.
yeah, yeah.
Yes, sir. At the joint, we have a rubber seal.
No, but how will you take
So
care
that-
of the slope, water? No,
With
because see, you are creating something not as a model.
Sir.
It's a life size,
Correct.
which has to work.
Correct.
Right? This is the roof, no?
Yes, sir.
Finally.
Yes, sir.
But how will the water drain? What is the slope of the roof?
Yes, sir.
How do you take the water down? These are questions which which I need to know.
Yes,
you
sir.
know,
So
not how you can fold it, how you stock it in the in the truck, and then how it has to be transported.
Sir.
But in reality, when I look at the model, my question is, how do you drain the water?
So we've given a 5% slope for the roof.
No, correct.
Which
But
is-
here, where is the downward? How is the rainwater getting down? In the sense, what will happen to the joint between the 2-3 panels? Between these,
sir,
yeah,
in
yeah,
between.
yeah.
Yes, sir. All of them, they basically the boundaries, the perimeters of the panels, they are rubber sealed. Silicon rubber sealed, so that we expect it to.
Not on a horizontal, no. It can be done. It is done mostly in the vertical surfaces. Yeah. Okay.
Give an example, that would be nice.
Yeah.
We don't have an example, sir.
And then even this, whatever, you have tubular sections on the periphery,
Yes,
right? And then how these wall panels connected to these tubular sections is also a point of concern.
Okay, sir.
Yeah,
We-
because
we
how
have
do you
looked-
seal it?
we have looked into that,
There's a
sir.
rebate in the edge where it gets locked. All these things are very important when you're looking at prefab.
Yes, sir.
Because the preciseness of each edge is so important here.
You can actually stand there so your other classmates.
It's an idea. It's basically an idea,
Yes, sir.
Because when you make a model, I think everything is expressive, no? The model is basically, it can show some sense of your thinking. I don't want this model to operate as a building, but an idea should be there, some attempt to think, But it's a good try, at least you attempted to make a model, which is very interesting. And all your lowers are reverse, the water will come inside. This
They are outward sloping, sir.
is it? Acha. Out,
Yes,
okay,
sir.
okay.
Actually, that is one of the main concerns, sir. In a construction worker housing site, a lot of mosquitoes, dust, and all that. So we actually looked into that. A provision of mesh behind the lowers also reduces all of that.
Okay, okay. Model is interesting.
Thank you, sir.
So you also had some negative embodied carbon. So I'm curious if you have a good response to that.
Sir, the first semester of sustainable design for us, very rudimentary basics, cradle to grave. So when we think about that, cradle to grave over the years creates a negative impact. So here the plywood panels are recycled. We spoke to the manufacturers, different layers. They use the shredded plywood in between the newer plywood sheets, making the negative, like bringing down the carbon emissions.
But how can it be negative?
Since they are using less of the new material.
But they're using some of the new material.
Understood.
Is there something negative? That's a question that we all
embodied carbon for a manufactured product, or even a natural product if it's traveling 1 kilometer.
That's it. You plugged it.
Yeah.
And you carried it. It's got energy. Yes. You put energy into it because you carried it from spot A to spot B.
Yes. It is slightly lower than the conventional plywood panels.
Yeah.
It is less.
It can be a lot less, but I don't see how it can be negative. I also found it, and not having looked at the numbers or the the simulations, but with IMAC for all except 4 months, Hyderabad is comfortable. I found that to be a bit incredible. So, I mean, who here is from Hyderabad? Anybody here from Hyderabad? Yeah. So all except 4 months, Hyderabad is comfortable. I thought that was not a claim that I could digest. So, yeah.
For a naturally ventilated building, we looked into that, sir.
Okay. So you ran some comfort.
Yes, sir. Yes, sir.
Okay. You mentioned 755 rupees investment per bed.
Per bed, sir.
So first of all, good work on getting it down to the per bed thing, because I think that is what the developer is probably going to be thinking of in terms of a per construction worker. What is it going to cost me? So over what period was that?
Sir, the life cycle of the entire module is for 15 years.
Okay.
So 755 comes down to per year per bed.
755 per year per bed. So per month would be
75.5 rupees, sir.
Okay.
Less than that.
Oh, less
sir.
than that.
Less
Yeah.
than that. Sorry.
Yeah. Okay. Yeah, that sounds.
75 rupees a month.
Per bed, sir.
Per bed. That's my cost.
For the construction worker, yes.
That's a bit too difficult to believe. 75 rupees, you can't get a meal here.
This is only for the beds. The kitchen costs are they are extra.
When he says when we understand it as bed, it means the whole enterprise.
Yeah.
It's not just the palang.
Huh.
It's not just the four. It's not the cot.
Yes. What does it cost to house a construction worker per month or per day? If you're paying a construction worker 600 rupees a day or 600 to 1,000 rupees a day, then what does it cost to house them per day? I reckon that's what developers are thinking probably.
And they will want to have the whole enterprise cost.
Yeah.
When you put it in terms of bed, hotels, hospitals, they are costed there like that. So
We
one
try to
understood that.
Yeah.
We try to do that, sir. Yes.
So
Figure that.
Yes, sir.
that was it for me actually.
Thank you, sir.
Hexagon. It is always befuddled me in a way, especially with the amazing logic that you guys have put out. Can you go to the your
The design process.
the heat thing, where in the roofs you actually claim that the radiation aspect on the roof is the least on a shape which is hexagon, which is a little difficult to understand. What is the basis? End of the day, it's an area, right? And how does an area have to do with shape? It's under the sun, and it's per square foot. How does shape have anything to do with absorbing radiation? My shape is red roof, right?
Yes.
A red roof is under the sun, right? It's directly under the sun. The sun is here, and the sun is, let's say, on this rectangle. How does this shape in any way reduce its absorption of radiation?
Yes, sir.
Or increase its U value, in short?
Okay. So actually, it is not only the roof, sir. All the surfaces of the shape, all the incident solar radiation on all the surfaces was taken into account. So that's how we got the least incident solar radiation per square meter of the surfaces. Not only the roof, sir. Actually, the roof will not receive much of the incident solar because
Suppose I have a thin rectangle in a certain direction.
Yes.
I can always orient it in a certain way, a thin rectangle. That would reduce it will be 50%. This is also 50% if I see 3 sides green, 3 sides whatever else. In a rectangle also I can get that, no? 2 sides. So depends on the I wonder if this conclusion is a bit too quick. It needs a little more detailed investigation. I think you've jumped a few guns here in your need to prove, you've kind of fell in love with the shape and you've gone a little running on it in trying to prove the shape, I think, which is a little, you're a little caught in there. Because again, you're increasing, if I now come to the critique of this form, in terms of numbers of joints, I'm also increasing the number of joints, I'm increasing the number of members, I'm increasing, my furniture layout inside is gone to, it's complex because of the shape. If I was to sleep in this room and put my furniture, I get these vague corners, acute angles and all that. So I'm increasing my complexity. So let us say for a minute, even if this was right, for a minute, I think there are a lot of other parameters before I make a decision that this is the right shape. See, I understand you're part of the SDI thing and you have to prove that radiation is and you have to come to zero. But I think it's a lot of things. No? They're asking you for affordability, detailing. They're asking you for a lot of things.
Whole building.
Yeah, so it's a whole overall thing that all those parameters, it should work. So in that sense, you probably just jumped a few guns and running ahead with this with an intuition that you had. It's still, some level one would want to believe it's an intuition and not fact. So that to me is still a little iffy there. Also, as I always, I said earlier also, when you have when you have this dismantling business and mantling things together business, couple of levels of safety are more important because it will never be perfect. Putting it back together is never perfect. Yes. So if my roof overhang is there, even if there's a little error in its dimensionality, my roof overhang takes care of some other problem. Okay. So those, because these are all, you're all building it like modern buildings. This, it's like the container box. But the container box is manufactured in a certain way and it's standardized and it's produced and it's worked it out and it's expensive, so but it's successful. And I think this is one of the questions I'm going to really have for every one of us here. When you're putting things out there, this is for all of us, out there in the market, you're really putting this out as an alternative to construction sector housing, right? So what is the most successful one that exists? Tin sheets.
Yes, sir.
Right? Tin sheets
GI
and metal members.
Yes, sir.
And they just put up you're fighting against that as one option. Second is now the latest is these containers.
Sir.
So how are we going to be in any better way than these two options is going to be a challenge for all of us, whether you use Recron panels, whether you use any kind of form and shape. So one could even dismantle one of these containers and see, okay, if I use the container structure and I just rechange the panels to all these new kind of,
sir.
Would that work? So to me, I think we've not really looked at the market, what exists in the market in detail, and broken it down and say, listen, I got to beat this guy. This guy is really inexpensive. There's nothing, because the tin sheet doesn't need any structure because it is structural itself, because the tin sheet is coming, given its steel, that the corrugation itself provides a certain strength. I honestly still do not know any sheet which I can span from one edge to edge without a central member, literally speaking. Just tie it at one end, at the other end, bolt it, 2 J bolts, and it's done. Even if a monkey jumps, maybe it'll bend a little bit, but it'll survive. Yes. So I think this is, to me, I see that as a huge gap, that as much as SDI is about certain numbers and wanting to prove it to be sustainable, it's also that it should work, end of the day, in all the parameters. So that's a thing that's been in my head. So this is just a general comment I had, because you're the last, I thought I should just share that.
Thank you, sir. Thank you, sir.
Yeah, as what he said, the shape, I think it's not, in any way, strengthening the whole structural system. If this were to be about 100 or 200, then this becomes a seed, which can become part of a very structural, stable system, So I think we need to look at, if this were to be horizontal, Imagine if this hexagon is in elevation. Yeah, I think that would have been a, interesting structure to me. Something like that, so that becomes more stronger structural system. On plan, it is just an assembly. It's just, like cutting 4 corners to make a hexagon. And the roofing is very important. You have a lot of wastages in the roofing. Huh? How will you take care of the roofing, because of the wastages of whatever sheets you are using. So I think that is majorly. What is the foundation you have looked at?
We've gone for a telescopic channel for the stilt, sir, which
No,
can be adjusted.
No, but it has to rest on some foundation, right?
Yes, sir. In case of high-speed winds in low altitude areas,
Right.
we have J-bolts. We have given provision for J-bolts, which will be anchored to the RCC foundation below the base plate itself.
Achha, there is going to be a
There is
RCC
bracing.
foundation.
Yes, sir.
Okay. This is in Hyderabad, no? Basically,
Yes,
you
sir.
don't know. Basically, you may hit rock. Who knows? Because most of the Hyderabad is rock belt. You can anchor it.
Sir.
That's it for me.
Thank you, sir.
One general comment, I think, since we are at the end. I do think that, when we do architecture, what do we start with? We meet the client, we gather the requirements, we design the program, we come up with a brief and, like concept schematic, go back a few times. And I just feel like with all of the designs, some of you went and spoke to construction workers before, but did you speak to any of them after? And also, would you want to live in these places if you were in those shoes for 12 to 48 months? I found by and large that was an element of like livability, habitability, that somewhere along the way we got too caught up with the whole 10 contests and forgot about the habitability. That was my kind of overall observation. So maybe you can go back to your construction workers and ask them that ye design kiya hai, rahoge kya? And then the other general the other general comment would be, at the end of the day, it is about the developer seeing value in this. And there are a few developers around today and tomorrow for the grand jury. So you may want to talk to them about,
Your partners. Right?
Banaoge kya?
You all have partners. What is it? I mean, we haven't heard. Actually, you should actually get your partner also to be here standing.
Yeah.
That's very important.
Yeah.
Actually, one of our teammate, it is their family construction company, and then he's not present right now with us. That would have been great. Could have accompanied us. So yeah.
But will he put money on it?
The final question, call up your family, and then we want to see.
So that
That's a sign.
that's what it comes down to, is, will your project partner actually put the money on the, solution that you've come up with? And whatever happens in this room is one thing, and tomorrow is another thing. But, if they put money on it, then you've already kind of succeeded. Yeah. So, yeah.
I think fundamentally, I think there's a lot of hard work everybody's putting in. I mean, you all worked the last, 6 months?
10, sir.
10.
9 to 10
Crazy.
months.
Yeah, great. Congratulations. That you have survived this far. That itself is an effort. It's not easy. I mean, obviously, you've got your other loads in regular school and regular stuff, and just you're doing all this. So that, I think, is great that you made all the efforts to be here. At the end of it, hopefully you will take back, everybody else's examples and your own, to see how close are we to being able to actually get it to reality, and how far are we. Now this is something, be hard on yourselves and be real, And just look at that. It is not about winning the competition. Winning the competition is one thing, but really winning is for your own self, is that search, that how far can I really, can this really happen? And in one of, at least in my experience, the simple test is, what is successful in the market? Can I beat it? Can I beat what is successful? So for me, the GI sheet is still unbeatable. So I'm really trying to find. I'm also, see, along with you, I've been these few months, we've all been struggling also to see how, what. And I'm not able to find an answer to the GI sheet, which is not only, for whatever reason, there are some bad things about it in terms of its energy composition, carbon. But look at its life. I mean, till the damn thing rusts and leaks, it's thrown around, it's mismanaged, but it survives. And it requires the minimum amount of, yet it's very hot, all kinds of other things. So is there a way I can find to fix that problem through design versus just simply throwing it out the door? And, and then the quality of detailing in the container. I mean, has anybody studied how well that container is detailed? It's so well detailed that that's why it's successful. It doesn't leak. I can pick it up, take it in a truck, put it anywhere. I don't need a foundation. It's like, so there are some key learnings in that, in both these kind of things. How can I better that? Till you will not better that, you will not be able to break the market in most aspects. And nobody's going to pay you double the amount because you are, cradle to grave, great. No builder. They're all there. You can ask them. If they have to put 200 rupees versus 100 rupees, I doubt. There will be some other pressure if they have to, but so these are hard realities, okay? So you got to home in there as much as, and so yet that is the struggle. Is simply putting new things and making new forms is okay for us all academic, we'll all clap, we'll all say hard work, nice, but the reality is very far in that sense. So that's my little take, but I must really appreciate the efforts and the seriousness with which you all have actually, come forward. So thank you.
Yeah, small. I think out of all, what I feel missing is that childlike innocence. I don't know, you guys have become so mature in your thought process. Where is the childlike, the plainness? I'm just only looking for that, that sharp energy of out of the box thinking. Where is that gone? That is what actually as jurors we are looking at. It's not of assembly of so-called well-programmed, well-thought-over elements put together. Is not what I'm looking at. Is there something which is an idea which is emerged out of your childhood? It's a simple thing, no? The requirement is simple, just good housing for the people who actually build buildings. They build big buildings for people to stay, but they deserve very sensible sleeping place. Correct, no? I think the brief is fantastic, no? How can you make it very simple and still, So we choose very complicated things and then we can't even, get a solution out of it. We spend solving all these problems. Why can't we look at something simple? I think that is what is very important from students. And when you are looking at, as what he said, when you are looking at, you can't be biased by looking at shapes, not just, what is the purpose and why it has to be used. And second thing, the relation between outside and inside. How do you look at sealing the outside? You know, how do you protect the inside from outside? You know, is very important. And especially when you are doing projects with kit-off parts, as an assembly, it is even more complicated. But anyway, fantastic try.
Thank you, sir.
We also enjoyed looking at all this fantastic learning for us also. Thank you.
Thank you, sir. Thank you.
Thank you, Team Tridara. Tridara, right? Yes. Okay. Yes. Yeah, thank you. Okay, so that was our last presentation on the on-site construction worker housing division for today as well as this year's Solar Decathlon India. Okay, congratulations everybody for being here, for participating in the event. Our esteemed jury has, shown immense dedication in assessing all your reports and the presentations. Jury members, thank you for all your effort over the last 1 month. We have been interfacing, we have been going through multiple reports multiple times, and we have been assessing everything. Thank you for being here. Thank you for all your insightful comments. A big round of applause to our jury members today. All the finalists that are here, thank you for coming. Thank you for participation. 10 months of effort. It's not easy going through 2 semesters. Okay, it's longer than 2 semesters. You have all your subjects, their exams, internals, projects, assessments, and you add this on. Yes, that process itself is an experience, is an achievement. Congratulations on being here. And I would also like to thank my team buddy, okay, Nivedita. She's been here, and she's been extremely helpful personally for me today to make this such a seamless experience, okay. I would have missed out of a lot of things otherwise, definitely. Thank you so much, Nivedita. Thank you. Okay. So this evening, after this event, jury members will stay here. They will deliberate, and they'll come up with the winner and a runner-up. All right. This year, we have a building industry innovation exhibit where you will get to see innovative building products that are addressing climate change. So the exhibit is now open to visit and look at the innovation. I think it's in the multiplex food zone area. It's near that golf ball building, okay? You'll have the locations, right? And online folks out there, so don't worry about missing out on it. Stay tuned on the channel at 6 p.m. to watch these exhibitors pitch their products to the Infosys jury panel. So they'll be pitching their products to the Infosys jury panel in the multiplex itself, all right? So until then, have a good evening. So jury members, I request